to it. Can I wait 1 second for Twitch to catch up as usual? Any second now. There we go. I should be live. Hello everyone, welcome back to one more stream. I have some time this week, so I'm trying to do as many as I can to try to make some progress on the refactor. So, current state, we're still in the middle of the refactor. We did a lot of work yesterday on struct type inference. So this evening, let's continue on the refactor. We're, I think, getting close to a point where we can try to compile some of the stuff. So, let's go. Yesterday, where did I want to continue this evening? There's a few things I wanted to do. I have some change. There we go. I wanted to go over some of the stuff we have written for the expression yesterday. I did realize there was a few mistakes. Well, not big mistakes, but things I could clean in the way some of this has been written. What did I want to do again? I might want to use this approach with a get compose rather than this traverse compose thing that's a bit inelegant. The final mapping is not used, so I can get rid of it. And something else that I will probably want to change. Currently in expressions in the validated version of the code, here for struct things, I have the struct type info here, the goal of which is like, yes, sure, those things are annotated with type information, but I don't want to have to like check, oh, I know it is a struct and I have to deconstruct, so I need to look into this. However, with the changes we've made, the struct type info is basically useless. So instead, I think I will want to have the actual struct info that is required anyway to resolve those things. Which means if we go back here, this is not getting the validated struct type. Here we are getting the struct info as part of this. There we go. So that's a small change that I wanted to make. There's a few more things I had spotted that I wanted to clean, but I'll probably like make a list and do that at a later point. Again, I think I like this version slightly better with the 4 that is explicit on what we are iterating. I will probably want to do something a bit similar around here as well. Okay. Next. Next, what do I want to do? I wanted to go back to the top level in here because we made a bunch of changes here. I think the big one we're missing is validating a type alias. That's something we haven't completely decided what the result would look like. So we're gonna have to figure that out. And we need to also finish validate function type and decide what needs to be stored in our state so that function instantiation can be performed after doing all of the top level declaration analysis. Which one do I want to start with? I think I might want to start with the function type because we already have some stuff there. So this is probably going to also return a definition validated. Oh, also, yeah, this is completely wrong. This is an enum info. Yeah, validate enum is just useless. There's nothing to do. I'm just going to remove it. That is just pure enum def info. There's nothing to do here. Function type. Do we have the type parameters as part of this? I believe we might, in the sense that we are going to call this function every time we encounter a function that needs to be instantiated. So we can register it, we can compute its type. Or maybe not, actually. No, maybe not. Maybe instantiation will be different. So no, I think this, I retract what I've just said. This will be looking at the top level declaration to decide, okay, what does a declaration look like, basically. well, do we have to do anything for this function? Let me think about that. We kind of want to have... We do want to have something about the type of this function in our scope, because since we allow pointer to functions, if a function value is, if function name is referenced in another function, we need to be able to say, what is the type of this thing? So we will want to store something in our context for each function we encounter. So yes, we want to do something. And I think the only thing that we need is the function type. So I think all of this goes away. I will keep the unless is generic instance, queued instance. That is, I think, correct. That is correct, I think. But I think all of this otherwise is irrelevant. Okay, so let's go look at the old core stuff and look at what we were doing for function type. There we go. We were doing all of this. Okay. Analyzing the type parameters is only useful for... is now done in the previous phase. We have already checked that they're valid. We have already registered them, so that there's nothing to do here. I suspect what we have to do is resolve the type of the arguments. I think naming is something... All the name stuff is done in the previous phase now, so all the name stuff is no longer required. Except we probably don't do it well yet. I think resolution... I think for function arguments... Yeah, we just... Yeah, we don't check any of the names there. So okay, we will have to make a pass over the resolution thing to actually check the names, because this is something that will make sense in this context, since this is the scope in which we will look at what is in scope and like try to do name resolution. So it would make no sense to create invalid scopes, so all name validation will need to be done as part of this phase, which we haven't done yet. Okay. But as a result, some of the stuff here is not required. For our validation phase, if we assume that the name have been validated, then this is purely a matter of translating the types and getting a function type, I think. So that means here, this is going to be, I'm going to do the usual thing, open common here to look at a function info and see what's inside. Okay, a function type and a block. And a function type is this thing. So here I am only interested in the function type. So I will want to look... I don't think I care. Do I care about the identifiers? Not really. I will want to have them in the function type thing that I persist, I think. Yeah, I will want to have them in the result of this function, because that way I have access to them moving forward. But I don't need to do anything with them at this point. I will need, however, to translate the type of the arguments, and I will need to translate the type of the return value. Okay, so let's do that. Let's use one of the traverse to there. I'm gonna just look quickly at what we have for expression, because I know I want to do basically exactly that. Okay. I copy that, put it here. So what we're gonna do is for the arguments, which I can lower this a tiny bit, which are a list of tuple of identifier and function archetype, we are going to traverse to of compose try validate function arg of the fields, which of the arguments, which is the fun args in this. In fact, I'm also gonna just do a function type here of the fun type of the info, which I think is the only thing I need. So I traverse the fun arguments to do a validate function arg, and I get attempt. No, I have another term for this. No, attempted is what I've used. Attempted args. Then I'm gonna attempted return, which is gonna be a very similar thing of a get compose of a traverse of compose try, and this is gonna be a validate. This is not a concrete type nor a partial type. This is a parameterized type, which we don't have yet, I think. Of the function return value. Why do I do this attempted stuff? It's because that way I will collect both the errors in here and the errors in here before failing if I cannot succeed without getting the result. So after that, I will have obtained the type of the arguments. I will have obtained the type of the return value, provided that neither of those failed. And I will be able to express that the type of this function is a function type, which is a list of function archetype, which we will have traversed, and maybe of a type for the return. Yeah, that looks fine, which means the result will be, or validated function info type info will be this function type info constructor lifted into the context of our monad by doing an ensure of the attempted arguments and ensure of the attempted return. If both succeed, we create a function type info with it that we get here as a validated function type info. The result of all of this function will be at the end a function definition that takes this new validated function type info. Well, yeah, I suppose that's about it. And here is going to be the change that we want to make. If it's not a generic function, then we need to instantiate it as part of this, the compilation of this unit. So it needs to be register for instantiation, which means we're going to put it in the queue of instances. What is that going to be? Doesn't need to be a hash map, I think. I don't think it needs to be a hash map. It needs to be something that uniquely identifies it needs to be something that uniquely identifies the function. So I think what it needs to be is a sequence of function instantiation request or something like this. And a function instantiation request is something that contains the definition that we're going to look at, which is the actual instructions that we need to translate, which is a function info resolved. It will contain the fun type, which is going to be the new function info, or a function type info, I suppose. And it will need to know the template arguments. Template parameters, which will be a list of type. And I think that's enough to then be able to do the instantiation of a given function. So what we need to do is, I never remember the syntax of sequence. Okay, it was that. So I modify the instances that have been queued by inserting a new one at the end, which is a new function instantiation request. Where the definition is something that we have here as an argument. The fun type is the validated function type info. And the parameters in this context is the empty list. And if that function is not generic, so therefore if it has if it doesn't have any type parameter, it can be immediately registered for instantiation. I'm going to put this let actually where it's used. There we go. That should be about it. We only need to do there's something wrong with my syntax somewhere. Yes, I am missing a do block here. There we go. We need the validate function arg function that we haven't done, which is just a case of by reference and by value. Excuse me. So by reference and a path, this will be a validate parameterized type of the path, bound up back in a by reference, and by value, it's gonna be the same thing. Okay, so that should be everything we need for function types. Let's move on to parameterized types. This is going to be in a different file, this one specifically. So we have validate type, validate partial type. We're gonna need to add a third one, which is validate parameterized type, which is in places where we expect to find type arguments that have not been replaced yet and that cannot be replaced. But we don't expect placeholders there. So let's duplicate partial type. I've already done that. For parameterized type, and it's gonna be basically the same thing, except I don't need to do a go thing for the placeholder and everything. The top level can be that. Up, there we go. So we're gonna traverse with validate parameterized type the path parameters, and then we have to handle all of those cases. Placeholder would be wrong. Oh, fatal no longer exists. It's called report nowadays. So this would be report. I probably have an error placeholder or something. I do have one. I'm sure it takes an argument. Gonna be unimplemented for now. Function pointers make no sense here. I don't think it makes sense here. I don't think it's something that can happen. Validate build date time is going to be the same. Validate struct type is going to be likewise defined here. In this context, partial types don't make sense. Here, actual must be expected. So if it's different, return an error. Okay. Oh, there might be something wrong here. Here, I don't attempt to resolve the parameters at all. I think that's wrong. Excuse me. Yeah, those are the wrong type. Okay, I think we have the problem in all three of those, so we're going to need to fix that. So those are the parameters. The actual parameters are obtained by doing a traverse of validate concrete type of the params. The same way that we do the same thing here, but except with validate partial type. And here we're going to do the same thing, where we take the params. Actual params will be traversed with validate parameterized type. Okay. So that should be better. What other differences do we have here? If we find a type parameter, that's just left and the name. Wait, do I still have the source in the role? That is in resolved. Do I need that anymore? I don't think I do need that anymore. So I think... Oh, those names are inverted. This is source, this is name. Well, I guess this is identifier. I think the source is no longer required for now. Enum will be fine. We just need to do a lookup of the enum to get the enum type. Excuse me. Had a long day. I guess I can implement, I'll implement enum later. It's not the most important at the moment. We already do this, this, and this. That's the basic. I guess enums are gonna be very easy to do, so I might as well do it. In expect, do I have expect enum? I don't. I can do an expect enum. Given the definition, expect that to be, it's gonna be actually gonna be closer to this, because I'm gonna need to have to handle type aliases there. But in the case of an enum definition with the enum info, I'm gonna be returning, what do I need to return for an enum? It depends. Here I'm trying to get the type, so the type information is what I want. So I guess what I want is just this, the base name and the identifier. That's about it. And the list of identifiers, but the base name I already have if I'm doing this lookup. So I guess here this is just purely returning the identifiers that we got from the definition. And the definition, we have not decided what it is. No, we have. It is an enum info. And an enum info is just a trivial thing. Where are you? It's that. So the only thing I need is pure of the enum values of the enum info. And this returns a list of identifier. Okay. And we are going to use this back in types. If I end up with something that claims to be an enum, I will need to check that. Oops. And this will be validating the enum type, given the base name and the parameters. In this case, this is going to be purely a when length. Oh. When the actual length is greater than 0, then we can report that because that means someone tried to give a number of arguments, of type arguments to an enum. That makes no sense. And I think the only thing we need to return here, this needs to be a type. That means I need to retrieve the definition of the enum. So I'm gonna need, if I go back to my expect things here and now I have expect enum, I can go back to context. And do a retrieve enum, which will contain I guess the only thing I care about, which is the name of the, which is the list of identifiers. And that's just traverse expect enum. Okay. I think this can be shared across all three because it doesn't have any particular weird thing. So this is something like that. Takes a base name. Oh, the params have already been... Oh yeah. Oh yeah, the params have already been validated. Okay. So I was wrong. Yeah, they have... Oh no, they have here as well. Okay. So no, I was wrong about the need. This is actual params. I need to do that. This is actual params. No need to do that. Okay. Well, except no, I don't need, again, actual params. I remove that line. Okay. I have 4 enums. What we have is the base name and the types. That's fine. I think that's about it. Do we need to return anything from this? I guess if this needs to return a type, then we need to get the values by doing a retrieve enum from the base name. And then we can output we need to output a type, which is going to be a enum type with the base name and a list of identifier, and that's it. So that's an enum type with the values and the list of identifiers, which is the oh, sorry, no, I'm wrong. That's the values, and that's the base name. Okay. So that means all 3 of those, I can replace this by validate enum type of the base name, and that should be fine. reducing the amount of work left to do. Oh, and the parameters, of course. Okay. I would probably need to wrap some of those in rights and lefts accordingly. Like those are gonna need to be rights. Okay. Type aliases is something I haven't done. I haven't considered yet. Ooh, I'm tired this evening. Sorry about that. To the point that I'm considering a break and coming back in an hour. Okay, but at least that's progress there. We've done the function type. Okay, I think at this point, if I go back to validate, the only thing I haven't done. So this makes no sense anymore. I'm gonna keep it around as a comment for now, but this will be replaced by function instantiation, which we will do which we will do at a later point. Next, I think the only thing left to do here is validate type alias. This one is going to be a bit of a doozy. So we have, if I look back at common, a type alias info here as an argument, which contains all of that stuff. And we're going to have to decide what the output of this phase needs to look like. Oops, not what I meant to do. I meant to do that. So that's a type alias info here, validated. Do I have a type alias info here? I do. I have the parameters and the parameterized type. Yeah, that makes sense, I suppose. So that means I am going to need to do the same thing of validating a parameterized type, as in output a type that points to the identifiers here. However, that also means, do I need I probably want to recursively go through each type. Although I suppose this will be done as part of validate type. So I think as far as validate type alias is concerned, it might be enough to do a validated value being a validate parameterized type of the alias value. And the result will be an output type alias info for now. That propagates the alias parameters and the validated value. Okay. Okay. That means the recursive substitution will have to be done in types. And that is all for type alias? No, that feels too simple. Plus, no, this needs to be wrapped back into a type alias def thing. Okay. Otherwise, that's done. We're done with the validation at this point. Because yeah, the only thing that matters is doing the validate parameterized type. That's the only thing that we need to check during this phase. Okay. Is that it? That's surprisingly straightforward. which means, I suppose, the thing we have to do next to handle them is to get back here to validate concrete type and so on. And to do the thing that translate type aliases, which is probably gonna be basically the same code across all three. The difference being how do we what's the type that we expect in the output, which means we might need to reify things. So let's think about this for a second. Let's do the easy case first. Let's do the concrete type. So I find a type alias. This is going to be a validate type alias type. That feels a bit redundant, but that's okay with the base name and the parameters. Validating a type alias type with the base name and the parameters is going to be retrieve type alias, which gives us a type alias info, the output kind, based on the base name. So maybe we should do that first. We're gonna need an expect type alias that gives me a type alias info. And this is purely the only thing I care about is a type alias definition, and that gives me the type alias info. Oh, I guess maybe if for those, the expect enum and stuff, I might not need to handle the type alias case depending on how that's implemented. Because let's see where I use expect struct and expect enum. I don't seem to be using expect struct anywhere. And expect enum is only used because here I have expect constant. That's wrong. That's expect struct. So I have it for retrieve struct and retrieve enum. Here that's used. Will that potentially be... No, okay, I might still have to do type alias shenanigans there. Yeah, okay. I'm in the context where I know that something is a struct, but I look up the name and I realize the name is a type alias. I will probably need to do some shenanigans there. So that means that those expect functions here for enum and struct will have to handle, okay, we found a type alias, but what we want is an enum. Let's continue searching recursively, basically. Which means this might create some cyclic dependency between this expect module and the retrieve module, which means I might remove this expect module and put it as part of the retrieve module, the context module, I think, to avoid circular dependencies between modules. But here I'm looking for a type alias specifically, so that's exactly what I need to return. I guess this one expects that. I think this one will need to be an internal compiler error. Because I don't think this would indicate... I think a lot of those expects are actually internal compiler errors. Not all of them, I suppose. Maybe they will give me. I need to figure out when I want to use expect as like no. Given the information I have, I know for a fact that this would be a compiler error if I didn't get the information. For instance, in the case of here, I know I found that the thing was supposed to be a struct, and I do validate struct type, and I don't get a struct. That should be an internal compiler error, not a user error. That being said, I guess I can always return an error, a user error, regardless, that it's valid in both cases, but if there's an internal compiler error, it's going to be weird. Uh, for type alias, I think this should always be an internal compiler error. There is never a case where I'm going to say, oh, I need this thing to be a type alias, and the user might provide something wrong. I will only use that in the context of I'm trying to validate a type alias, I think. So I think this one will be an internal compiler error. With this one, I can go back to context, retrieve type alias, and that is retrieve definition, and then traverse with expect type alias. And the output is an output type alias info. Okay. So that's the retrieve type alias from the base name. I get the type alias info. And now what I need to do is I need to aha. So here I'm gonna need to do a resolve parameterized type, I think. No, this is gonna need to be a concrete type because I am trying to find a concrete type. That means everything in scope must be known, but that means I need to add the type arguments that I know as in the context for the scope. Okay. That's why I have the source of the type parameter. Except I think it's the other way around, right? Yeah, it's the source and then the base. Well, name and source are bad both. That's the type, that's the base name of the type, and that's the identifier. Or param name. Maybe type name, param name. Okay. So what we have. Hello, how are you? So what we're gonna need to do here, this is something I haven't worked on yet during this refactor. We are gonna be carrying around in our context a mapping from identifier to type, as in we are in the process of looking at a type, what are in this context for the type parameters that we might encounter their actual type. Since we are no longer doing any type checking on generic functions, we'll always have a concrete type. What that means, however, is that we need to make sure that here, since we are doing type alias replacement, like, okay, we know what the arguments were given, so we need to add to this hash map the corresponding values so that we can perform a replacement. The only thing is, this requires base name and identifier to be in the hash map. Okay. So what we're going to do here is we are going to create a mapping from those two things to a type. So that's the type alias info. Oops. I'm gonna put that back on common. There we go. So we have the list of the parameters. We have the base name of the type. So we can create, and the type is this. So the mapping is going to be a list. It's gonna be, I'm gonna be zipping with something on the left hand side, the list of identifiers, that is the alias params. And on the right hand side, this is the actual number of template arguments, which is the params, which means I need to add this check here likewise. The actual is the length of the alias parameters. Oops, nope, of the params. The expected is the length of the alias parameters. When those are different, we can return that. And here we know they're the same, so we can do the zip with. And we have the param name and the param type. And what we return is a tuple where the key is base name param name and the value is param type. Which I guess I could just do a normal zip and then a map left or something. This is readable. Somewhat. Yeah, I can probably do better than that. I can probably just do a zip of map base name, comma, of the left-hand side. There we go. That avoids a function like this. Yeah, that's better. Okay, so now we have the mapping. We can add it to our context. So I'm gonna need to look to see I do have a lens, current params, perfect. Which I'm gonna modify to do a union with a new mapping, which is this one. Perfect. So now we've added the new things, the values for the current context. And with that, we can validate concrete type, which is what we are doing here, of the alias value. This will get us the actual type while doing a substitution of like, oh, we know that the argument is int, therefore whenever you encounter the t thing, replace that with int, basically. And this might do things recursively, which is fine. Okay. The last thing that we need, I think, here, and I think this will be always the same in all contexts. I think we cannot provide like a different number of arguments for type aliases. For type aliases, they cannot be. Could I provide? Could I decide? Is that valid? Let me think for a second. So a thing I allow by design is this. I have a struct S that takes two arguments. I'm not going to call it pair. I'm not going to, yeah, S1, and it takes two arguments T and U. And it has two fields X of type T and Y of type U. What I allow is in a constant X, which I'm not going to type, which is wrong, but just to give you an idea, if I create an S1 value, I don't have to give the type arguments because they can be inferred from the value I give for X and Y, int and character, respectively. But I also allow putting placeholders like this, or, not all placeholders, or placeholder and int, or which would be wrong in this case, something like that. Now, what happens if I have a type S2 of T is S1 of T and T? That's valid. Here, should I allow this? Should I allow this? This would mean that the type argument to S2 is not given. This would translate, therefore, S1, S2 would be resolved as being the actual type S1 with nothing and nothing here, so both empty. Yeah, that should work. I see no reason to refuse that. Like S2 like this should be valid. Okay. So I'm wrong. This function will have to be different for the other cases because we will want to allow the number of arguments to not be the full thing in the context of a partial type. Okay. I might want to extract this into a separate function because I do it all the time. This would probably clean a few things if I were to do it. So let's actually do it. Let's make a helper function somewhere here. Validate param count. Takes some list of identifier. Takes some list of types, whatever they are, I don't care. Returns something in the monad. And that is just expected params, actual params. Recompute the length. And when it's different, we throw an error. The only thing is, do I want to change? Yeah. Validate params count with. And this is going to be something with a first argument, which is going to be what am I trying to check? I am trying to check that the actual is some comparison with the expected. And that means I need a function from int and int to boolean. And validate params count is just validate params count with, and by default it is equal. Unless this function on both of the values returns true, we report this error. Okay, so now that we have this, there's a bunch of places where I can just replace with actual. There we go. Here, this is going to be validate params count with. So equal is the valid case here. And it is actual first, expected second. No, it is expected first, actual second. So the expected is the alias params, the actual is the params, and that is done. Here, this is validate params count, where the expected is the expected params, perfect, and the actual params are right there. That's a bit cleaner for sure. There we go. There we go. Here, this is even better. This is... Actually, I need to be careful. I need to be careful. I might have already messed it up. I think I already messed it up. I need to be careful. This one is fine. The only thing is, here expected is an empty list. Okay. I have messed it up because for a partial type, for a struct type, here this is a with. What is valid? Inferior or equal, not equal. That's the whole point. Okay. Perfect. And so the last thing I'm missing here is I will want to do a retrieve parameter from the type name and the parameter name. And that is going to be I'm tired. A retrieve type parameter will be getting the type from this. Retrieve type parameter will be given a base name and an identifier. That give us a validate of a type, and this will be retrieve type parameter. This is gonna be a uses context params, and what we do on it is a lookup of the base name and the identifier. I guess type name, param name. And if we don't find it, I think that's an internal compiler error. That is a case where like that thing is supposed to be in scope and we forgot to put it in the scope. I think that's an error on our end, not on the user's end. I think if it were an error on the user's end, it would have been caught during the previous phase when we do the name resolution. We would have realized that like, oh, there is no parameter t in the scope. Here we're like, oh, okay, we found it. We found the t that we're talking to. This is a type parameter. Therefore, we know it's valid. Therefore, if we don't find it here, that's an internal compiler error. Type parameter validation. Parameter name not found. And show the type name and the param name and show of the parameter name. Okay. With this in scope, I can go back here. This is just retrieve type parameter. Okay. Ah. There is a problem. In my context, I am saying that all type parameters will always be known. Like they're always a type. That is not true. That is incorrect. Something I could do, but that would be ugly, is to not put an actual type or like or partial type or something like this at this scope. But instead, I put the unresolved type information that must then be resolved every time the thing is called. But that's ugly as hell. No, I need to find a way to have something that's not necessarily a concrete type there. Because in the example that we were trying to do earlier, that I already removed, where we use a type alias in a struct expression, that one, we need to be able to say, well, moving forward for the type alias that we're doing, for the resolution of it, the type t of the struct that we're actually expanding maps to a missing parameter, so a partial type. So here, this cannot just be there is a possibility, which is that this one only contains the top level function 1, which must be always concrete. And since the other one only appear when going recursively, then those functions take an additional context as argument when trying to resolve recursively, which is the only place where such partial types might occur. And that context is used to distinguish them. I think that's the good solution. I think that's the correct solution. Which means we are going to need to change retrieve type parameter to be a bit more complicated, but that's not the end of the world. That means that we are going to introduce a go function. So this is going to be go with no mapping. And we have our recursive function go, takes the path info as an argument, but also the local mapping. That does here everything we have been doing. But if whenever we when do we do a recursive validate concrete type? Here we do one for type alias. Is that the so here we are calling it, so this is going to be replaced with go and the local mappings, because we are going recursively over the type arguments. And for all of those, the only case where we need to go recursively yes, we don't validate the struct here because we do indirection for structs. So the only case where we are going recursively is for type alias. And that's going to be with the local mappings. And those are going to be so I'm going to need to give them as an argument here. So new mappings are going to be the union of this and of the local mappings. No. New mappings is going to be from list of that. And what I'm going to give here is the union of the new mappings and the local mappings. There we go. Okay, so validate type alias type here requires the local mappings to be provided. And type parameter will be validate type parameter. I might just call that validate type alias. I really don't like the but I want to make sure that I'm distinguishing now. Okay, type parameter type, local mappings, type name, and param name. And this is going to be validate type parameter type, local mappings, base name params. So what we're going to do is the equivalent of what we've been doing on other things so far. If I go back to context, like those retrieve functions, so this is going to be I am performing a lookup of base name params type name param name. Let's be consistent. Into my local mappings. And if I don't find it, I perform retrieve type alias. That's what it's called. Not type alias. It's retrieve type parameter that I want. Oh, did I need to do that? Retrieve type parameter. No, it exists. Okay, perfect. And I can do this in a different way. I can do this as just a lookup. So the type of this will be do a lookup in the local mappings or nothing if it's not found in the local mappings. Then do a retrieve type parameter of the type name and the param name. Okay? And that logic will allow us to do things for partial types where we have mappings that contain partial types. And those here at the top will be the ones only for the function itself, which will always be concrete. Okay. With this logic, I'm going to copy some things. This takes the local mappings as an argument. This takes an empty as an argument first. Okay. Excuse me for a second. Okay. So here the difference is going to be, so we look up the type alias, we validate the parameter count, that's all good. The new mappings will be the parameters. This is exactly the same. And this is going to be, okay, so this function is exactly the same. I can generalize it. I'm going to put it one step higher, I think, in terms of order of functions. Yeah, it belongs here. So it's going to have a type similar to this one. Except it's validate type alias type. And it needs the local mappings. The base name and the parameters. Okay. Now, where that's complicated is what the types are going to be. Oh, it needs the callback function as well. It needs to know what's the go function to call, basically. So it needs the local mappings, which are gonna be a hash map from base name and identifier to some kind of type T, which will be dependent on the context, concrete, partial, or parameterized. it will need the base name, which is very conveniently a base name. It will need the parameters, which will be a list of those T types. And it will need, before all of that, oh, I guess I have to be more specific. Those are not, they are typed node of F. Because I will need to do some magic at the end. Okay. That's the kind of type I'm talking about. That's the kind of type I have my parameters. This is the kind of type I'm returning at the end. And this only requires one more thing, which is the callback function that, given those mappings and a path info resolved, will give me, I'm gonna make it as, I'm gonna make it more readable like this. It's not perfect. Gives me the result. That's the callback. And that callback I'm gonna call as an argument F. Not very imaginative, but F will do the job. And so there's going to be union new mappings, local mappings, and go recursively. Okay. I might be able to get away with actually just T here because I never need to exploit any particular shape of this. So T is probably fine here as long as they are all the same. Because the local mappings are there. I'm returning the type alias. Just checking here that the length is the same. That function will accept any list of parameters. Yeah, that should be fine. Okay, so now this is deduplicated. So I can replace. This one can go away. And the function I'm giving as an argument here is just go. Likewise, so partial type, go. Okay. For type parameter type, I think I have no choice. I could possibly transform a type into a partial type. Do I have an FF map? I do have the FF map. Okay. And I have this abstract function. Perfect. So abstract is what I want. So I should be able to write this one as a generic one as well. Let's try. This doesn't do any recursive stuff. That's great, which means the type is going to be a lot simpler than this. So this doesn't take a callback function. This does take the local mappings that are mappings to some type tree of F, where F is an applicative. I take a list of those type tree of F, and I return at the end a type tree of F. Type tree happens to have an instance of HKT like this. which means I will be able to actually, will this work for identity? Yes, it will work for identity. Where's the two spaces there? So this is going to be, I do a lookup in the local types, which are already the correct type. If I don't get anything, I do a retrieve type parameter, and I need to transform that because it will be a concrete type, something where the type thing here, f, is identity. I need to transform that into whatever this thing here is. Is that H pure? I might not need, no, it's not H pure. I think it is abstract of pure, basically. Let me think for a second. No, I think this is correct. Yeah, I think this is just here I have to fmap something onto this. And what I have to do is abstract pure. Okay? With that done, that should be fine. And that means I can, in this case, remove validate type parameter type. I'm done to just validate struct type. Likewise here. And here the yep, traverse go, perfect. Did I do a traverse go here? Go local mappings. I forgot that. Traverse go local mappings. Don't know why there's another line. Ah. It's fine. And like finally, last but not least, I need to do the same thing for parameterized type, where this will be the same thing as here. This is a go MMT. And that is going to be the content of the go function. While taking as a first argument the local mappings. And this traverse with go and the local mappings. And I can copy that for type alias, base name. For the type parameter where I have the type name param name, I can copy that as well. And with that, I think we have done all of the type resolution that we need, except for some of the expect stuff. Yeah, there is one thing. There is one thing. Let's see. If I go back to expression, if I look at this validate struct type here, oh, I don't do an expect there, that's fine. Expect type, that's wrong. Oh no. Huh. Okay. Wait, I thought I was using those expect thing. Oh, but I'm using retrieve. Oh, retrieve struct. That one is a local one, it's fine. This one is the one that's problematic. Because this one... Ah, no, it's also wrong. Okay. So this one is also, given the name, I am checking that I do have a struct, and this is a place. Oh no, this is fine. This is fine. What I'm trying to figure out basically is, would it be correct to have all of those be internal compiler errors rather than being um, user errors? And I think it would be correct because I think we never use expect in a context where the user could have provided something that is wrong. I don't think we ever do that. No, here we do. Well, no, actually, we don't. Because if I have validated the struct type, that means I know I have a struct, so it's fine for. So I know this is a struct, therefore the base name must be a struct. So yeah, no, that is valid. And this one, likewise, yeah, I think all of those retrieve can be. And the retrieve. All of those that do an expect. Wait, why is it? Yes, of course. I think all of those expect functions should actually be an internal compiler error. Okay. Type alias, not a type alias. Yeah, I think we've established that whenever I use one of those expect or one of those retrieve, it is always in the context where I have validated that the type was of the right shape. Therefore, If I do get a type that says, hey, this thing is a struct, then retrieve struct definition should always work. Do I need... Aha, and I should not need to handle type definition, because whenever I do a retrieve definition, I should do it on a resolved type. I have actually I've been through all the type aliases, so I know the actual base name of the struct, I know the actual base name of the enum, therefore those should never be type aliases. We don't have to handle them here. That's good. That's for an enum. So here, likewise, no need to handle this. Not a fan of having a bunch of functions that do internal compiler error like this. And I think I'm gonna rename, I'm gonna change those. I've been trying to like have a naming system for my functions to be able to know at a glance what they do, or at least group them together. I think the expect ones that might fail normally will be like expect is this is what I expect, but if it's wrong, it means the user messed up. I think those that if it's wrong, it means I messed up should be assert instead of expect. Which means that in context here, those expect becomes assert. I think we're getting close to a point where we can try to compile. We're nowhere near. Now we have two big things missing. We need to fix our type for the AST for the validated version. And then we need to write our diagnostic monad that we are assuming the existence of, but I haven't actually written yet. But after that, a lot of code will still be missing from after the refactor, but we should be able to start compiling things and see where it breaks and start fixing things. Okay. Because now we should be done with type aliases. We should be solving them recursively properly. So all the type shenanigans should be done. Okay, so I think it is time to clean the AST thing. Because I have kept this old version that needs to go away. Validated here as well. And probably common too. So what I want to do here, what I'm using for my AST is I'm using the trees that grow approach. What that means is, and I'm underutilizing it for now, but I have this thing where like I have a series of type families where I'm saying, well, depending on which phase I'm in, I have different types I should be using at different places in the AST. Currently, I only have this one, the name type, which is used in a path. So if I go to path info here, when we are in the past version, we use the name type of the past AST, which is just a path. Like we know that this is a.b, whatever a.b happens to be. And in the resolved version, where we have done all the name resolving, then we know that a.b happens to be the b function in the a module. or the B field in the A thing, like whatever, like, well, it's not the same syntax, but you know what I mean. Like, we have resolved what that path means in this context, but the AST is the same. We just change what the type in path info points to. But I'm not making a lot of uses of this yet, and I've created validated, which is this thing, to be the new version of the AST post validation, where I have a lot of specialization and way fewer generic things to make future faces not have to recheck assertions. For instance, now the left hand side of an assignment is an L value expression that I know by construction is a correct L value, which means if the validation succeeded, there is no way that an invalid L value made it to the left of an assignment, that kind of stuff. But that means I'm gonna need to change, if I want to be able to like reuse statements and everything across the different things, I'm gonna have to generalize for the type validated as well. So I will need my own version of this here, validated, and there will be an AST representation for validated. Okay, so first, I go back to common, and I change name type, because name type is terrible. This should be something about the path. So I guess this is the path type, I suppose. Well, this is in the path info. This is what the thing points to, which is either a path or a role. So that should be the path body, I suppose. So in path info, I can replace that as being the path body type. Okay. In validated body type, it is void, in a sense that like it makes no sense. I should never have a path info by this stage, so void is fine. For parsed, it should be path. And for resolved, it is role. Yeah, I fixed the wrong part. Now, another one I'm gonna need is expression. The whole thing of being able to do this is I'm able to have a different type of expression in the output of the validation phase than I had in the previous one. I happen to be able to reuse the same between common and between past and between resolved, because the shape of the AST doesn't change. So that means I will need an expression type here. I'm gonna add the constraint here. This is path body type. This is expression type. I'm just gonna align them vertically because it looks nicer. Okay. That's the common one. For past, the type of the expression type for the past phase will be the common expression passed. Okay. For the resolved version, would be that, and I'm gonna include, I think the source import of the name is no longer required, which is good. Okay. And for validated, resolved. And for validated, it will be not the common expression, it will be the expression in this module. I'll need to quickly check past. I'm going to make this qualified as, so it's very clear which one I'm referencing to. I'm going to change that in resolved. And I'm going to put that in validated as well. Okay. Name is no longer required as they import like this. Oh, something is wrong in this file if it doesn't auto align stuff. Okay, interesting. Now, that means that I need to change a lot of things back in common. Because now, every time I have an expression, I will need to change that to be actually whatever this expression type is. Also, I realized I made a mistake. In past, an expression will be a with location of a common expression past. For resolved, it will be a with location of a common expression resolved. And for validated, it will be a typed expression where we have no longer any line information because we should not need location information further, but we will have type annotation after this phase. Okay, let's go back to common. Let's go to, there we go. This is a with location expression P that is no longer correct. This is an expression type of the phase. Here, likewise, with location something, that's just an expression type of the phase. And in fact, I'm just gonna do a replace of with location expression P with expression type of P. Which means now, if I reuse something like a if info across different phases, it will use the proper expression type, even for validated that use a different expression type than the common one. Okay. What else will I need? The definitions will have to be different because here the definitions, I have those common ones there, but I will probably want to change them because there is a lot of information I want to persist from one to the next, and there isn't really a good it's not really a good idea to just, because I want to keep this definition thing. It's useful. The only thing is, what I want to persist for this struct after validation, what I want to persist for a const thing will change based on the phase, which is why for validated, I have different stuff. I have this type alias info that's different. I have this struct info that's different. I have this function info that's different. Actually, this one might be really similar. The only problem is types. I could change for more reusability. I could say that like, oh, here this return, rather than being a path info in all versions, it delegates to the trees that grow, and it happens that path info of the phase is what I have for both pass and resolved, just not for the next version. Because in validation, what do I put for a function type? That's a validated function type info, and function type info, that is something that's specific to validated. It's this thing. But it is basically the same thing. Okay. But no, here I cannot, because it would need to be parameterized by, like, I can't reuse the function info thing that I already have here. Unless, no, because I will need to, hello, how are you? I'll need to be able to give the f parameter, which means there will not be one function info type per. So here I need to use a different thing. However, I don't need to keep the function info here that is separate. Oh. No, those are actually different things. Okay. So when I put a function type info in a definition here, this is always with a parameterized type. Okay, so let's do that. I am gonna need to decide what is a function info type at a given phase. And that's a type. Which means here in common, this is function info type of P, because I'm just gonna not bother with vertical alignment on this one, just because here I need to fork to something else for functions. Okay. Function info type. Because the whole point is I want to really reuse things like definition, which is useful because a lot of it will be the same. And I really, really want to be able to reuse statement, because the shape of statement doesn't change from one phase to the other. It will always be the same, which means the only thing that needs to change is what the expressions are within, hence having this expression type kind of thing. And if there's other things that need to change, I'll just make more type aliases for them. So function info type, that's changed. For past, it will be convenient. The function info type for past is just the common function info past. For resolved, I'm just gonna copy this. I'm kind of tempted to, because here I'm just using an arbitrary type as the key. I kind of want to go back to the idea of using data kind to restrict what the argument must be to just a enum, basically. I think that'd be better. And this is a function info resolved. However, in the context of a validated AST, it is slightly different. The function info type here will not be the common one. It will be instead a function type info. I think I can just remove this function info altogether. It will be a function type info, the local one, parameterized by f, which happens to be the either identifier, which is this thing here. Okay? So the whole point is that I can remove statement and block. Those definitions will all be the common one. Now for validated, and if info, what's in there? Expression block, yeah, it is the same thing. So I can get rid of this. That's the same thing, I can get rid of this. For info is the same thing again. That's not true. That's not true. For 4, there are a few things I'm gonna change. Because here for a 4 info, I am persisting a few things after validation that I don't have before the validation. So that means either I make this range expression. No, I think I just need to make the 4 info different. That's the best solution, I think. So here, this will be an identifier. That's going to be a type. Range expression, this is local. That's a common block validated. And that means I need yet another thing. I need a 4 info type family. I'm going to add it here as well. To be able to point to the right thing. And that means that in statement, where is it? Where are you? Here. This is no longer 4 info, this is 4 info type, which delegates to the type family so that I can decide which one to use depending on the phase in which I am. And in past, the type of 4 info type past will be the common 4 info past. For the resolved version, it will be the resolved version. And for validated, it will be the local for info that is not the common one. It will be the one that we have here. Okay. Go back to common. While info, is it any different? No, it is the exact same. While info doesn't need to be different. It's going to be the same structure in all three of them. That's fine. Let info. Aha. That is interesting. That is interesting. In the version that I have in the past version, the let info contains, well, maybe there was a type that was passed and there was an expression, but here I have a typed expression, basically. Because I have resolved the type of the thing, I have resolved the expression, and I have confirmed that it matches. So I don't need... So this is going to be different. Okay, so that's fine. We do the same dance. We do the same dance. So the let info type is going to be different. Which means that in statement here, this is a let info type that delegates to the type family based on which of the stages of the compiler we are in. No, okay, well, it needs to go away. So in the past version, that is just the common one that we keep. For the validated version, well, let's do the resolved version first. It is also just the common one. For the validated version, it will be a bit different. It will be not the common one, it will be the local version. Okay? With this, is there anything else here that I have that is not... So the function type info indeed is different. I might have to do more stuff for definitions. Struct type info, yeah, okay, this one is no longer required, that's fine. Type alias info. That's going to be different, yeah. Where is it here? And it's already part... Oh, it's not yet. Okay, so type alias info is going to be different. Okay. Enum info is the same in all phases because enums are trivial. Struct info is probably going to be different as well. Okay. Const info is probably, yeah, it's going to be different as well. There's no const info in this version. Okay, I think for the definition, I'm almost tempted to just change definition altogether because rather than listing, all the types are going to be different anyway. So maybe I don't reuse definition. I make a definition per phase and I choose where I branch in each phase. Maybe that's the best solution. Typed here is the thing, and then I have the expressions, which are different. And I think that's all. Okay, so now I need to figure out the definition problem. Because what do I put in... Oops, I have some stuff that's not saved. Yeah. When I validate a function type, I return a function definition that contains not this. Well, it contains the function info type, that's correct, but that points to a different thing at every in different phases. When I validate a struct, I return a struct info, but that's a different kind of struct info. So this is different as well. For a constant, I just put an expression. This is different as well. Yeah, the only one that's the same across different phases is the enum. So I could make a type family for each of those things, or I could say that actually the definition is different in the context of a validated thing. So function info type goes away. And what I have instead is I have a definition type. Oops. There we go. And that means in parsed, I'm going to remove this. I have no longer this, but I have this and a definition type parsed is the common definition parsed. In resolved, that's what I have. Oops. Here too. But, you know, resolved. And in validated, I will just introduce a new type altogether. It's going to be easier. So the definition type will be a definition as defined in this file. And in this file, a definition, I'm going to look at common, will be something that's eerily similar, but also just not the same thing. This is a common enum info that hasn't changed. But this is a type alias info as defined in this file. What do we do for a type alias info? It's that. I don't have it defined here? I thought I had. Oh, I do indeed. So I'm going to put that with the definition here. It's this type alias info that I have. For a struct info, it is the same. I guess I could just rename this struct info here. No, it is indeed a struct type info. That's two different things. Struct type info is the one that is present here as part of the type stuff. And in the definition, I have the struct info, which is the one that is used for the definition. That is not the one that is used. Oh, I need to move this into function type. That's the downside that this resolution is I have so little screen real estate that it's difficult sometimes to see the structure. Let me know if this is too small. I've zoomed out a tiny bit just because I'm moving things around. If it's too small, I'll zoom it back in. Because here I want, okay, this is all the type stuff that goes together. So I'll probably have like some separator at some point here to like indicate types and stuff when I put comments. Then that's the definition stuff. with type alias info struct info. That's this struct info here. For a constant, I'm not putting a const info at all. I'm just putting a typed expression. A typed const expression, even. And for a function definition, I'm just putting something else. I am putting a function type info, so I'm just reusing the thing I already have for the type. Okay. Oh, but this is not any function type info. It is parameterized, and this will be with which is what I had here. This is parameterized by this f here, because it is a parameterized type within. So it is this kind of thing. I'm almost tempted to give an alias to this thing so I can reuse the same here without having to, but I think it's fine. It would be very, very explicit if something goes wrong. Okay, type name will be a function at some point below, I think. So that's the definitions. And then I need some kind of function info. I need some kind of function info for my symbols. What is my symbol again? So that's a definition type validated. And that's probably... Well, I could probably instead just say that is... I'm tempted to have, for those things, each module re-export a bunch of things. So this is a validated definition. This is a validated function info. And this is a with location of a resolved function info. Okay. That means I do need a function info invalidated. Can it be the same as the one in common? Why is a function info in here? Identifier, function type, and block. What's the one I have here? Do I even have one still? I don't seem to have one. The problem is function type, I think. Function type will not be correct. So I probably need to have something else. I probably need to have my own function info thing as part of the validated version. Okay. So the function info in this... Hello, how are you? The function info in this phase of the AST, in this phase of the representation, will just have... What do I need at this point? I need the type. I do need the type. So I will need the function type info. Do I just want to call that function type in the same way that I call that function type here? I might want to actually also keep... And I probably also want to keep the parameters there as well, I think. Keeping it very close to this, in a sense. And actually, I think in the context of the validated version, I will probably want to always have a return type because I have a unit type. So I know that if the type was not provided in previous version of the thing, it is unit. So I always have a type there. So I think, yeah, I'm going to rename this the function type because it is almost the same thing as this one. Okay. And I think I will include the function parameters as well. I think those might be needed for when I do some type replacement in the thing. Now, the function info, the name is no longer required at this stage. I will just need... Wait. it is the same. If I have something to point to the correct function type. But I can't necessarily point to the current function type. I could. It's probably fine to redefine it. I think it's fine. So a function info is a function type, which is this function type. And in the case where I need this, it is a case where it is all concrete, so it's an identity. And it is a common block validated, which then reuses all of this of the stuff. Okay. So now I think we have made use of all of those. Definition is different at different phases. Although, to be fair, I might not even need to have this because I think I have nothing that actually contains definitions. So every phase I can just choose what type to represent. So I don't need that, which is good. It could just be a fancy function to produce a complex pair function. What do you mean? I am not sure what you mean. So I'm not sure if I have thought about it. Oh, something else I wanted to do. I wanted to add the new AST phase thing, which is we are either passed or resolved or validated. And here, the p argument to this is not any type, it is actually an AST phase. There we go. Which means that in AST proper, I am no longer exporting this, I am exporting AST phase, I think. Probably just exporting common for now. Although I might want to change that, but I don't know actually if I can. It'd be nice if I could have if I could export something named resolved that was import. Can I do that? Can I do module resolved while importing this as resolved? I know I do something like this in my prelude, but it doesn't work that way, I think, because here I'm importing the thing as a thing and I'm exporting. Okay, so I need to look it up. Okay, it doesn't seem to be possible. That's fine. That's fine. So, yeah. I don't know if I will even want to keep this file. This file might make no sense. Or maybe as documentation, perhaps. I'll think about it later. So for now, back in common, I have the AST phase, the type that matches, and the things that we are forking. How do we present a path at a given point, like in the AST? And for this, each phase has a different answer. When we are just parsed, we say that it is a path, so definition is no longer required. When we are resolved, we have a role instead. And when we are validated, we have void because there should no longer be a single path in the IST. So if we ever try to have a path, we'll have a void and it will not be able to instantiate. Now, what kind of expressions do we have across a thing? We are using this expression type, which for common will be the common expression that is in there and will be different for each phase. So I think I'm going to rewrite this. This is no longer the generic AC. This is common, well, common AST definitions, I suppose. Shared across different phases. For instance, the function type is the same across parsed and resolved, therefore it can be used the same. Like a lot of those are the same across the different versions. But whenever needed, for instance, in statements, rather than using a let info and a for info, they use a for info type and a let info type to delegate to the appropriate version based on the phase. Okay? And here that's the basic expression that will be completely different based on the phase. Okay, okay, okay. So parsed should be relatively easy because it is just defining this thing to use the common ones and defining how we group things after they are parsed. Like this is a module and this is an import statement, things that only make sense after we are done parsing. I could start adding some color by adding some comments. Okay, so that's the only thing we need. What is a module? What is an import? Those things only make sense in the parsed version of the AST. Everything else we are delegating to one of the common ones. And I will probably want to include some type aliases for things that are common across different. So I can use the like past definition or resolve definition. I will probably re-export. I think I will want to have a few things like the past version of a definition is a common definition past. And I think there's very few types I need this for. I think definition is one of them. I will need, however, to be very careful to always say definitions are using. I guess I can use the definition alias I've just made. This is this kind of definition. And I think I have nothing else in this file that depends on common. Perfect. Let's go to resolved, which is the second phase. Oops. That's not required. So here we're saying the path body type is a role, the expression type is a with location common expression resolved, and we are using the normal, the common for info, let info for those things. Here are the definitions that are exclusive to this phase, the resolved phase. This includes role. Aha, and this is a common function type. This is a common function archetype. That's a common path info resolved. Okay, this is no longer something that is required because we are dealing with constants differently now. So this can go away. And I will copy the re-exports, and I think definition is likewise the only one I care about at this point. A definition resolved is a definition resolved. There we go. Some of those extensions are probably not required. I don't think I have lenses anymore in this, so I think I could probably remove all three of those. Probably true here as well. I don't think I have lenses, and I don't seem to have any kind of weird instances or anything like this. Oh, unless this instance is weird. Maybe it is. Maybe I just need it because of that. I guess I can remove it. If it's wrong, the compiler will complain loud and clear. Do I still have in common? Do I still have any pattern? I don't seem to have any. I do have lenses here, however. Okay, so this is all the common stuff that I probably should not be using directly. Okay. That's fine. That's fine. And finally validated. It's no longer required. Oh, I should import a few things from common directly. In all three cases, I want to import the name of the phase, which is, so I want the AST phase, I think. I want the same thing in past here. And I want the same thing in resolved here. So I don't have to say common resolved every time. Here, this is still the same type family, but now we have a bunch of different things. And I might... No, I'm going to use the same thing of like definitions and just group together the things that belong together. For this phase, we have a new thing, which is a type, which is all three of them are type trees, which is this thing where I use a higher kind of type using a f functor that wraps a type node, which is this nonsense. And I renamed this to function type, right? Yes, so I don't need function type info anymore. That's just function type. However, here struct type info is the thing here that I'm using. Here, the point of type is that it kind of inlines all of the type information for a given thing. Like, oh, I have resolved this thing to be actually a character. You need to like, void whatever. But for those three more complicated one, I include like enum, what's the base name that uniquely identifies this enum, so I can, when I generate types for the LLVMIR, I don't have to generate duplicate types, for instance. And for a struct, that's the same thing. That's how I find the correct struct. its base name and the corresponding types. And not having inline the actual information also means maybe I could just inline this nonsense. Do I have a lot of struct type info left in place? I have a few apparently. Interesting. Okay, so since I have a few, I'm gonna keep it separate. Right, again, it is just what definition am I pointing at? What arguments do I give to this thing? Okay. Oh, function archetype is probably no longer required, or at least it's not required here. Ah, wait, function type is... No, it is parameterized by the f thing, but for a function info, I know that it is a function type identity. I am almost tempted to rename type into concrete type for readability. I might do that. Concrete type is a type tree with identity. And I think to avoid a few things, concrete functor is identity. Type partial functor is maybe. And type parameterized functor is the either identifier. Which means now I can rewrite this as oops. There you go. Wait, I'm an idiot. This is what I meant to copy. There we go. Now I can do that. There we go. So it's a type tree with a concrete functor. A partial type is a type node with a partial functor, and so on. Which means now whenever I have one of those identity or either or something... Oh, sorry, I had missed your question. Let me just finish this and I will answer it. So here, either identifier, this is now the parameterized functor. And I know I have a few identity in a few places. Yeah, this is now the concrete functor. Okay, what I'm doing at the moment is the analysis phase. So there's the parser phase that gives me the AST, the parsed AST version, this version of the AST. Then there is the whole analysis phase that transforms the AST several times until it gives me the fully checked, validated version of the AST, at which point almost all of the errors that come from the user have been found. Then there's the lowering into IR when we generate an intermediary representation. Then there's the code generation that generates bytecode. And then there's the assembly linking kind of thing that generates the image at the end. What I'm doing at the moment is this big analysis phase that does all of the checks from the parsed version of the AST all the way down to the fully resolved version of the AST. It was one phase before the refactor. And having that was creating a lot of problems where I had only, if I go back to common, I had only like parsed and resolved phases of the compiler, of the analysis. And the representation of resolved was still a very naive representation, very close to the parsed version, which means even though I had performed all of the checks during this analysis phase, during the next phase, the lowering into IR, I would have to constantly double check everything I had already checked. For instance, here in the common version that was used for both, an expression like this, an, in an assignment, the left-hand side of an assignment is an expression, because there might be more than one kind of assignment. You can be assigning to a variable, which would be, of course, a path expression that points to a variable. You can be assigning to a function argument that you override, which would be a path expression that points to a function argument. But you can also be assigning to a field access expression, which is the field within a struct, that kind of stuff, which is why there is an expression type on the left-hand side of an assignment. However, obviously, not all expressions are valid left-hand side of assignment. Like a Boolean OR is not a valid left-hand side of an assignment. You can't do A or B equals. That makes no sense. So, of course, during the analysis phase, we would reject that. We would check, is this thing on the left-hand side a valid left-hand side for an assignment? But since the output of the entire analysis was still using this same thing, I would be outputting something that still had an expression type on the left-hand side, which means that my next phase, the lowering into AR, would see an assignment and be like, well, I still need to check that the left-hand side is one of the valid ones. So what I'm doing is I'm splitting this gigantic analysis phase into two parts. The first is purely about naming and scope. I have a name A here. Does it point to a function? Does it point to a type parameter? Does it point to a function argument? Is it a constant? What is that thing? That's the thing for which I have the path body type kind of thing, which is used in path info, which is like a path expression, for instance, using path info, but a type is also a path info. And it uses a path body type to say like what is the part of the path, basically. And in the past version, that's just literally a path. I know I have like A, whatever A is. And in the resolved version, where we have found all the name, I now have a role that tells me what the thing is, where, okay, the role is a built-in type, a built-in function, a struct, an enum, something like this. And yes, the idea is I use a slightly different version of the tree at every step. And before, they were like 90% similar. And now what I've been doing for the last half hour or so is differentiating a bit more the things at different stages. And now that I have separated the things and I have a new output at the end of the validation phase, I have a new and different expression type. And now this thing doesn't have a path expression. It does have a local variable expression, a reference argument expression. It has like a bunch of things like this that are a lot more explicit, where I don't have to check things down the line. For assignments, for instance, it no longer has any expression on the left-hand side. It has an L value expression on the left-hand side, which is this new thing, which I know by construction is necessarily a correct left-hand side of an L value expression. So that's the idea. I am differentiating the tree more, like the representation more across the different phases, and I am splitting the one big phase that does everything into smaller phases so I can do more incremental changes. So the thing I was doing earlier was like deciding what types can I reuse across different things. The main thing I wanted was in common here, I define a bunch of things like statement. A statement is an if, a for, a while, a let, a return, a continue, a break, or just a raw expression. That does not change across the different phases. So I want to keep this the same. I want basically to be able to just reuse the same thing. The only difference is what kind of expression do we have within. But if info, else info, for info, like those are mostly the same across the different phases. So what? Yeah, exactly. Let value like this. Like, I'm using the C++ term for this. And what I'm doing is I'm using like the trees that grow approach, where I basically have this big group of type families, where I'm saying, well, okay, my AST is 90% the same, but there's a few places where I want something different. And for instance, what is an expression type at this phase of the AST? Well, it's this type given by this type family. And when I've just passed the thing, it is just the common expression one that has like all of the expression unchecked. But when I'm done validating, then the new expression type is this new expression that I've been using that has a much more specific kind of information. That way, when I do, the main reason I want to do this is I want to try to make things that I have checked, like I want to the types that I have in the output of the analysis to reflect the checks I have made. To take the example I was saying again, if I have checked that the left-hand side of an assignment is a valid L value, I want the types of my output to reflect this so that I don't have to have a bunch of internal compiler errors in my next phase that just recheck assertions that I know are already correct if my compiler is correct. So that's why I'm doing this refactor and why I'm splitting things. There is also another upside of splitting name resolving, okay, this path here in this context, what does it mean, with the broader validation checking, type checking, and so on, which is the instantiation of generic functions. Because I'm doing there again kind of a C++ thing for the generation, the instantiation of generic functions, which is that generic functions are not instantiated until they are used. So if I have a module A that defines a generic function foo that has a type T parameter, but does not instantiate it, it is not included in the symbols of the module A because there is no concrete version of that function. However, if I have a second module B that imports A and uses foo of int, then foo of int becomes a distinct symbol that becomes instantiated. Before, when the analysis was doing both name resolution and type checking at the same time, I had to redo all of this, including the name resolution, every time I was instantiating a generic function, which means I had to keep track of, okay, which generic functions have I imported from other modules, and what is their name scope? Because I need to do the name resolving for them when I try to instantiate them, as if they were still in the module in which they were declared. Now that I no longer have this, as the output of my name resolving phase, my generic functions are included in what the module has resolved. And for the instantiation, I no longer need to do the name resolving. I can just do the type checking. So it's having split them simplifies a lot of the handling of generic functions. That is what I'm doing at the moment. The big downside of this gigantic refactor that I've been at for, well, I took a long break this, like the last month or so, but is that I have not been able to press compile for probably 20 hours at this point. So when I press compile, it's gonna be fireworks. That's gonna be fun. So here, this file, I know there's something wrong with some of the code in there because the parser doesn't work, the auto indenter doesn't work. So there's something wrong that I need to fix somewhere. Which is also a good occasion to go through this again. I wonder if there's something like the type annotations here are not recognized by, because I haven't enabled the probably haven't enabled the right compiler extension for this. But however, type node here is correctly defined. That looks good. That should be fine. Yeah, that is what is wrong. Yeah, okay, and now that has this fixed. Okay. I will probably want to move this function away from this. Maybe... Because that's not something that is part of how the AST is defined. That is part of the helper functions, I suppose. I can put it in. I can keep it in this file because it is alongside the type that is defined. Okay. Oh. Yeah, okay, this needs to move away from this. Just for organization. Why do I have the lenses here. Those are wrong. I think because they have been copied from common when I created this module in the first place. I think a lot of those will be wrong. Not all of them will be, though. I do define a few things in this module. So here, let's go over this again. I have my own definition type with my own type alias info, my own struct info. I'm not reusing the ones from previous version. And I will need a function info. Our function type info no longer exists. That's just function type. Here, I'm using my own for info and let info. I'm using this typed thing. And then I have my const expression. And range expression. Oh, actually, range expression, although I don't do ranges yet, I will probably want to have something a bit different because there are very few values that will. There are very few. Here's an example of where I'm gonna have to output something that does not fully reflect the checks I have performed. Very few types will be able to be in a range expression. There will be, I think, only basically int and character in the built-in types, and I think that's about it. But the expression on the left-hand side could be, it could be not just a int constant, it could be a function call. It could be function call that gives me an int. But I will have checked that those expressions are correct. They're both the same type and they're both like int or something like this. But the types will not be representing the fact that I have checked this. And the expression here could be things that makes no sense, such as a range expression within or an assignment expression. Maybe I will want to introduce a more specific type for ranges to be able to avoid representing invalid ranges for the output. But since I don't support ranges yet, that's a problem for later. Okay, so I have for info, let info typed, and struct type info. Those will need lenses. Oh, do I want to keep the plated? Do I want to keep plated for expression? Doesn't hurt to have it. And I probably want to have it for const expression as well. And it's going to be a lot easier to express now that I no longer have to deal with the annotation kind of thing. Oh, the ones in common are going to be completely broken by the lack of annotation information. Wait, do I still have any annotated? No, okay, I've removed all of that. That's good, I think. That's going to make a few things a bit easier. Oh, I no longer have... Huh. I no longer have that plated thing, however. I probably want to keep it for this expression type as well. How is it defined? It's still in the AST file, I think. Because that's the old code that I haven't removed yet. Yeah, that's how it was defined. I'm just gonna copy and paste it. Oh yeah, typed expression. Is typed expression still a thing? No, typed expression is no longer a thing. Would be back in common. Okay, just gonna copy this version. Oh, except that doesn't make sense anymore. No, okay, that's just fine. Okay. Except, yeah, I think none of this will compile within no longer exists. Yeah, a bunch of things are going to be different. That's fine. We'll fix it when we get there. But I do want to have plated for my special expressions there. You will probably want it for the L value expression as well. But let's do it one thing at a time. So, plate of one of those thingies, which here is array values, which is going to be x, I don't know, xs, is going to be, I'm going to traverse with f of xs. I think that's what it is. And I need to recreate after that a array const expression on the result. This has a struct info. Wait. No, it has a struct info and this. So, oh, by the way, plated is a lens thing for self-similar types. Like this is a lens that examines the things of the same type within it. Const expressions contain const expressions, expressions contain expressions, and it allows to do things like rewrites, where I take an expression and I apply a function that does a rewrite recursively. So it's a very useful lens for this. I have still somewhere, it's going to be completely broken given the scale of this refactor, but I do have a simplification phase that currently operates on a thing resolved. Maybe I will want to instead operate on a thing validated. That does some very basic things. For instance, it uses this rewrite thing to say, well, the left-hand side plus a 0 is just the left-hand side, remove the plus 0. The left-hand side minus 0 is just the left-hand side, that kind of stuff. And it performs the thing recursively, so it does a bunch of simplification recursively. It is currently expressed as being on the resolved version of the AST, and I think that's no longer correct. So I think I'll have to rewrite this to be on the validated version of the AST at some point. Okay. But here I'm doing the plated stuff, so I have the struct info, that doesn't change, and I have the fields. So what I'm going to do for those is I'm going to recreate a struct const expression with the struct info. And this is going to be a traverse 3 because it's within a non-empty list, within a tuple, within a typed. So this is an fmap 3, or traverse 3 in this case. Actually, this is probably a traverse 2 as well. Of f on the fields. Do I have traverse 3 in my prelude? Oh, come on. No, I don't. Time to make them. fmap3 is for 3 functors f, g, and h. I have a function from a to b. I have an fg of ha, and I want to create an fg of hb. And that's fmap, fmap, fmap. There we go. Traverse 3, if I have a third traversable T3, and I have this A to FB, and I have a T1 of T2 of T3 of A, I want to create an F of T1 of T2 of T3 of B, and that's traverse, traverse, traverse. There we go. So that's gonna be a traverse 3 of the field. I'm just gonna abbreviate this just because the line length otherwise is gonna be unbearable. And otherwise, there is nothing to do because we are at a root node. So that's just gonna be some, just gonna name it X. I'm not very original. And that's just copying this. Up, there we go. Oh, I need to also check the lenses. A bunch of those are wrong. Module doesn't exist. Import doesn't exist. Path info doesn't exist. Type alias info. Struct type info. Enum info, no. Struct info, yes. Const info, no. Function info, yes. If info, for info, if info, no. For let, yes. Type expression is a thing that no longer exists. For the prisms, import type, no. Definition, sure, why not? Functionality type, yes. Statement, no. Else info, no. Expression, yes. Const expression, and L value expression. Okay. So that's the plated for the const expression, which is a lot simpler than it used to be. Now let's make the one for the expression. Yeah, I'm just not gonna bother keeping the old code since it is basically irrelevant now. Oh. Yeah, I suppose that for the ones that don't contain anything recursively, I can just... Since it returns the same thing, for any other thing that is not an array constant expression or a struct constant expression, I can just return a leaf, and that's pure of the leaf, unchanged. Okay. I can do the same thing for expression, where anything that doesn't contain a recursive sub-expression doesn't need to be included. That doesn't contain anything. Function type does not contain expressions. Call expression does. Expression. Oh, why is it not a typed expression? Oh, I suppose I don't need to have the type here because I know for a fact that the left-hand side of a field access expression will be a struct, the type of which will be captured by this, I suppose. Although, I still think I want the typed because this will give me the base name and everything that this does not. So no, I want a typed expression there as well. Those are leaves. I don't need them. Those are all recursive cases. Aha, and then I have range expression, and that is different. So here that would be a leaf. I cannot apply... Yeah, unless I use a function on plated that can work on any of them, which I think is not what this does. I would have to do... Wait, am I doing something wrong here? I think this might be wrong. I think this might be wrong because I'm never applying F, actually. I mean, no, my simplifier works, so I don't think that's... Let me look at plated for a second. Wait, it was already open somewhere. Yep, there it is. I don't know, it does just not return anything for the Okay, no, okay, that's fine. Okay, so yeah, we apply the transformation on the recursive things, but not on the base elements, because yeah, otherwise it would be applied. Yeah, okay, no, that's fine. So this version is correct. Okay. Okay, so yeah, I could always do a plated on an expression that includes in the function that it transforms the expression, a plated for the sub-expression, and so on. That is doable. So this is not something that this particular thing cares about, so all of those also go away, and as a result, all of the others are considered leaves as far as this function is concerned, so pure leaf, and that's fine. Can remove a lot of white space. I'm going to group all of the binary things together. There we go. Because all of those will have the exact same shape. To the point that I'm just going to do a replace regex. That's going to be easier. Because all of those have some constructor name followed by typed expression followed by basically a bunch of stuff. So there we go. And this is going to be replaced. Actually, I'm going to do that here. This is going to be replaced by the constructor followed by the same constructor applied on f. Well, actually, the constructor needs to be named. It has left-hand side, right-hand side. And this is going to be the constructor f mapped into f of the left-hand side and applied then on the f of the right-hand side, which I'm actually going to rewrite as being a lift a2 of the constructor of f the left-hand side and f the right-hand side. There we go. So an index expression left-hand side, right-hand side is a lift a2 of the index expression on f of the left-hand side and f of the right-hand side. That's the recursive transformation. Okay. Oh, the CAS expression is annoying. That's fine. So we have the left-hand side and a type. And so what we do is we create a cast expression by applying f on the left-hand side and pure of t, which I might want to rewrite there again as a lift a2 of this, and this. And might as well align it because it's basically the same thing. Those are unary thing, so they don't have left-hand side, right-hand side, they have just one expression. Oops. And they both do the same thing, which is to apply this constructor into f of the expression. That's a lift a, basically, which is basically an f map. I have one too many empty lines here, I think. Yeah, there you go. Then what do I have? Field access expression. Those are tricky. So this is... Oh, I'm wrong. All of those are not... Yeah, they are typed expressions, so I'm not applying f on the thing. I am doing a traverse f of the thing, because f is applied within the typed. There we go. I think this is also true here. This is traverse. It is always traverse. For a field access expression which has, which I've removed it, it is the struct info, an expression, and an identifier. Wait, didn't I change that? Didn't I just change that to be typed? Didn't I just change that? I thought I had. Did I change it in common? Nope. Huh. I was convinced I had just put this as a typed expression. Oh, maybe I did that. I did that in the typed L value expression, not in the... Yeah, okay, there we go. That's why. Okay, so this is, again, for a field access, it's struct info, doesn't need to be recursed on. Typed expression needs to be recursed on. Identifier doesn't. And what was the last one again? Identifier, it's not. That is a lift A3, which is a bit inconvenient, but that's the way it is, of the field access expression. Pure of the thing that doesn't need to be changed. Traverse f of the expression that is typed, and pure fn, the field name. For a struct expression, that's just the struct info and the fields, and that's a lift a2 of a struct expression. The first argument is pure. Well, I don't need to do that actually. I could just do a lift a2 of this with this. And I can do the same thing here. This is a struct expression with this f mapped into traverse 3f of the fields. We're almost there. An array expression that's just some values, and that will be an array expression f mapped into traverse 2 of the fields, and a call expression, name, function type, and traverse 2. So that's just a name, a type, and the arguments. And the result will be a call expression with the name and the type f mapped into traverse 2 f of the arguments. This is traverse 2 f. There we go. That should be plated for expression. This doesn't exist anymore. Range expression will be subject to change, so I'm not going to bother about it for now, but L value expression is something that I will want to be able to do plated on. So, instant plated L value expression, where plate of f is a function that takes one of those thingies. I hope I copied and not cut. Yeah, okay, we're good. This is no longer required, within no longer exists. Those are roots, it's fine. Those are not. This is, and I can just probably copy field access expression and index expression, which are the valid things that can be on the left-hand side of a assignment. Just gonna outline this for readability. Okay, and that's just those are field access L expression, index L expression, field access L expression, index L expression. Everything else is the same. Wait. Oh yeah, okay. Okay, that should be all for plated. And with that, I think we're getting very close to a point where even though so much is left to do, we can try to start compiling things and see where they break. And break they will, without a doubt. But we can start having a look. Okay. Now, no, there's a few things still we need to do. Interface, I'm gonna need to change. I think the AST is just a module I'm just gonna remove entirely. It should no longer exist, I think. I don't think scope is something that needs to be in the interface anymore. Scope is purely an implementation detail of the resolution phase. Here I need to know what a scope is, but this can go, I think in the resolution monad here. A scope is a hash map from path to non-empty role. And I will need to do all of the scope creation that I haven't done, but this will be done as part of this phase. So it's no longer part of the interface that we output because we never need to know that anymore. Aha, so I will probably want to have, yeah, function info as well in the re-exports, because a function cache will be a cache of the resolved function info, while the symbol cache will be the validated function info, validated definition, okay? So I need resolved at the very least. Since resolve doesn't define its own function info, to do here a function info, which is the one that's going to be used, which happens to be common function info resolved. Okay, perfect. So that's going to be the interface. Now, the validation monad. Here, a bunch of things are going to change. I'm going to remove this name input, output. I'm going to just import them qualified. Maybe I won't need them. I won't need common qualified. I don't know. We'll see. So here, for instance, the local definitions will be the resolved definition, the ones that I have from the previous phase, while those cache are the ones that I have defined in interface. Types not required. Function instantiation request, it's a local thing. Validate context as well. Okay, everything here is fine. This function info resolved, so that's a resolved function info. I'm going to be very explicit again about which one I'm talking about. This function type info is something that no longer exists. That's just a function type. That's a validated function type. Validated function type. Ah, which is this thing. Which one does it need to be? It needs to be one of the concrete functor, because we will need to know the exact type of the thing. Wait, I thought function info contained... Ah, but the function info contained the function type. This, yeah, okay, so I will need that as well. So I will need... Okay, I have validated the function type, but I have not yet done the definition. So validated function type, that's correct. And type, that is indeed a validated type. Maybe since that one is not ambiguous, maybe I can import a few of the things here, such as concrete type. Oh, that's a change I've made this evening that I have not yet fixed. There's a bunch of places where I've used type, and it should be concrete type. Not here. Not here, which is good because now it means I can use the proper type here without having any interference. That's good. Typed is not okay. Parameterized type, parameterized type. That, however, that's a concrete type. That's a concrete type. That's a concrete type. And then that's all, I think. Nope, there's one here. A cast is with a concrete type. Okay. Okay, what else am I missing in this? I think not much, but in the monad here, I might want to. So I will need... Here, those are concrete type. Show the parameters. Oh, I might not need that anymore. This might be part of the function type. Function type will contain... Oh, no, it doesn't contain... Okay, so I need that as well. Oh, then this function type needs to be parameterized by the concrete functor. I will need to know. I will need to know the exact concrete type for each of the types in this, because a function can only be instantiated if it has all of its types provided, if it is concrete. So concrete type, concrete functor. I guess I can just import everything from this and also import it qualified. Import as validated, I suppose, like this. It's resolved. Okay. So that I don't need to specify validated on things that don't require it. Okay. Next, the context. Base name location may be concrete type. Base name identifier concrete type. Those lenses are wrong. This is validate info, validate state, validate context. Analysis doesn't exist anymore. This is all validate. Otherwise, it's correct. Except the type here is wrong. This no such thing as a path info resolved. This is a concrete type. And here this hash map is from base name and identifier to a concrete type. Actually, I probably don't need... it's fine to have it. As I say, I probably don't need the base name in this hash map, but it's fine to have it. It doesn't hurt. Okay. With context, that's all correct, except analysis M doesn't exist. This is all validate. I'm still not entirely sure whether I want... what my naming convention for my monad should be. Should this be a validate T, since it's a transformer that adds a capability on top of the underlying monad M? But a validate T with the usual convention of how the MTL is defined would imply the existence of a validate, which is the root of a monad stack, and the base, I should say, which makes no sense. Since validate will never be used in any other way than this, is there a point in naming it validate T or validate M or something like this? Maybe it's fine to just call it validate, and part of its definition is that it stacks on top of something else, I suppose. So I think I'll keep validate as it is for now, at least. Okay. Anything else that I want to do? I will have to do the monad diagnostic at some point, but I'm not going to do that right away. I think. Yeah, it's a good point. I'm not sure which one I want. I agree that like having the suffix t to indicate that it is a transformer is the convention. I don't know if there are cases where people use a non-t like a non-t name despite it being a stack. Yeah, perhaps I should just indeed rename it validate t because it is based on the reader t, based on the state t kind of thing. And I just don't have to offer validate if validate t doesn't make sense. Yeah, I don't think it's a big deal, but I care a lot about this project trying to be as readable as possible and therefore closing like good naming, good conventions. And I also want it to be consistent. So if I decide that T suffix is the correct approach because it will be the one that makes the most sense and is the most understandable for someone who reads the code, then I will make all of them with a T suffix so that it's always very clear. So now let's have a look at validate and word boundary and replace with validate T. Okay. The thing is, I probably want to actually go back to the resolution phase because there's so much I haven't done there. Well, sub-phase, I suppose. This is part of the analysis. Here I will do resolve T then. Zero occurrences. That's convenient. Okay. Oh, but run resolve T then should... Oh, I probably messed up my replace regex then. Yeah, I did. Okay. Run resolve T is the thing that unstacks this thing. Run reader, run flip exec state T. Okay. Okay, resolution is somewhat straightforward. I think the only thing with resolution is I haven't done any of the name checking, excuse me, which despite being some kind of validation needs to happen at this phase because since this is, I am creating a scope and I'm then checking what a thing is based on the current scope. I don't want to insert in my scope names that are invalid. For instance, I don't want to allow a let variable name if put in the code or something like this because that would just break everything afterwards downstream. So I need to do the name validation during this phase, and I have not done that. It is, however, a much, much smaller phase compared to the gigantic validation one. So it should be a bit easier, I think. Because a lot of this will just be iterating through. Aha, here I'm going to do the same thing again. I'm going to get AST resolved as resolved and AST passed as passed. Because I'm going to need, this is a passed definition. Do I actually care about the location? Wait, yeah, I do actually. This is wrong. Things can fail, and if things fail, I need the location. So, this is resolved definition. I will need to do the same thing I do for the validation, which is that I update the location. Ah, that's within context. Okay. Ah, yes, of course. Yeah, that's a bit different. Okay, so for resolution, I'm still gonna need to do that. Oh, I do have the context here. So I could just do RC location. Okay. So whenever I have something that has a location, I should do RC location is... Oh, I do resolve definition. That is very wrong. That is extremely wrong. What the hell? What am I doing here? What is happening? Do I have any other call to resolve at any point? Do I need to call to stack things and call resolve recursively? I don't think I ever do that. So why do I have the scope like this given as an argument? The scope will always be the top level scope. That's how I start. Then the scope gets modified as I go through the thing. Hence, the expand scope with type parameters, expand scope with function arguments, expand scope with variable, and so on. But yeah, no, there's absolutely no reason for this scope to be given as an argument. Although, I guess... No, it makes no sense. It makes no sense. I suppose it would be good still to put some stuff in the context every time I start a validation so that it has access to it. Or do I want to run the state per validation? No, I think I want to share some state. It's going to be easier. Because clearly for the validation phase, the state is shared across different validations. Here it could be, since the scope, the only thing that matters is the top level scope. Since the only thing that matters is the top level scope, I could, in theory, run the resolve monad on each definition independently. There is no need for me. There is no need for me to keep the state, the resolve, across different things. Which means, if I do that, I need the module name, which is a base name. I need the declaration name, which is a base name as well. And I don't need the location, that's just wrong. Not like this anyway. That's part of the state. And so to run a resolve T, I need the module name, the declaration, module name. Oops. The declaration name, the top level scope. I don't need an initial location. And some action. The resolve info contains the module name, the declaration name. Anything else I judge to be worthy to have in this thing. And the context contains the top level scope. I guess I need a location no matter what, so I suppose I can give the starting location. So there will be the declaration location. There we go. For readability, I'm just gonna put this here up, make this line a bit smaller. Okay. So that means that here resolve will need to give me... Oh, this is completely wrong. Yeah, this is entirely wrong. Okay, that's fine. So we will get a with location path definition. That's correct. But first we will get the module name. Do we need the module name? We probably don't need the module name. I don't think we have it for the validation. We do have it for the validation, okay. And therefore that is not a base name, that's a module name. Therefore here that's also not a base name, that's a module name. So here we'll need the module name, the base name of the declaration. And that's it. And now we'll need the top level scope. And we get a with location of a path definition. And we return in that monad M, whatever it is, and this will need to be monad diagnostic when we have monad diagnostic. This will contain the with the resolved definition. Okay? So this will be a run resolve T. Since nothing needs to be shared across different definitions, each definition can be resolved individually because no definition, once the top level scope has been established, no definition has an impact on the name resolving of any other. So this is going to take module name, declaration name, top level scope, declaration location. So this is, just gonna copy copy this. So this is run resolve t of a module name, a declaration name, a top level scope, and the location of the definition. Which will set the location and everything. And what is the action that we do in this resolve t monad? It is a traverse resolve definition of the definition. Okay. So now is where we have all of this that makes a lot more sense, I think. Except this is a past definition, and this is a resolved definition. I think most other types are in common anyway, so it will be fine then to just use their suffixed name. Okay. And now all of those are just take the thing and return something in resolve, which is the resolve version of it. That's all good. Most of that logic should be fine. I think I do the name checking properly here because every name name checking must be performed whenever I put a name inside the scope. So here I do call validate binding on each type parameter, which means if I have a type parameter that is a reserved name, or if I have a type parameter that shadows something else, I will... Oh. I no longer use fatal and report. I've been using report and warn so far in the validation. So I need to adjust. Here, likewise, for a variable, I validate the binding, so I will always put the right name into the thing. And function arguments, I validate the binding as well. Okay, so I do check the names. That's good. I think the only names I no longer check are the actual top level name, because I no longer have the code that creates a top level scope. That's a thing I'm gonna need. And I think everything else is... I'm gonna rename this as path body to be more consistent. Yeah, it's only used once. It's only used once here. Path body. Okay. So now this should all be fine. Because most of resolve basically is just traversing the entirety of the tree to go to path and resolve the path, while doing some basic scope manipulation at the same time. Because resolve block, for instance, resolve block, where are you? I take the scope as it was at the beginning of the block. I initialize block with whatever variables are, like a for loop, for instance, needs to add the variable, and at the end, I I restore the scope to the parent scope. So anything that was declared within the local scope is popped when I go back up. I could like use an actual stack of scopes, but it's easier to just reset the value to what it was. Now, I think the only thing that's missing is creation of a top level scope. I no longer have this. I have the old analysis code here that has the old analyze module function that is no longer correct. I will want to make that as part of the resolution, I think, because to resolve a thing, I need to create the top level scope. So that's something that's missing at the moment. Let's go do it. And maybe I will split this and move this scope manipulation into another folder within this, just to... none of this exists anymore. Okay. Just to avoid having the thing being too crowded. So all of this is the code. I'm going to move this as being scope. So I'm going to create resolution scope. I'm going to copy all of the imports. Those are purely internal, I think, except, I suppose, scope creation. Those will be re-exported throughout the top level module, I believe. And I want to move this to a... I don't want to call that util, but calling it validation is really stretching the number of times I'm using this word. Name validation. Let's be very explicit. There we go. And here I can... Okay. Half of this would not be necessary, but it's just... Okay, I'll fix that later. Okay, so now in scope, this is where I will want to move the scope creation functions that I no longer have, which are part of the old code. And I think they were part of old core. God, this old version pre-refactor worked, but was extremely complicated. I am happy with, even though we're nowhere near done, I am a lot happier with the current state of the code. So create foreign scope, create local scope are the two functions that I need. Although they might be completely wrong now. Aha, net diagnostic M. That will be correct at some point. I just don't have it yet. So here I'm saying that I have for each module name the set of identifiers. I will probably want to change this actually. And maybe I just want to have the full interface. Like, hey, this dependency has been analyzed, and here is its interface. And this is indeed a scope. I think that is how a scope is defined. Scope is a hash map from path to non-empty role. So creating the local scope is indeed creating a scope. Oh, this is not in the validation monad. Yeah, that makes sense. That resolution monad, that makes sense. Because I don't need access to any of the things. So this is probably correct still mostly. So that is for a module name, the scope that we get from it. We'll really need to decide what is fatal, what is report, what is warn when I do the monad diagnostic, which I haven't started yet. Maybe tomorrow. I'm not sure if I'll be able to stream tomorrow, despite tomorrow being the regular Thursday stream. Today being a irregular one, because I'm getting my COVID shot tomorrow. So if I end up being extremely sick from the shot, I will not be able to stream. I tend to have a pretty strong reaction to the shot every time, so we'll see. I'll have to decide how I want to do this. So here, top level declaration. Yes, that is correct. Okay. I think I have no reason to doubt this code. It hasn't changed, the types haven't changed. The only thing is the use of fatal, but when I create the monad diagnostic, I will decide how the functions are named. So this is when I will decide between report, fatal, warn, how I want to call them. So this is something that will change. Plus, I think I will actually have to decide per phase for reasons we'll get into. So that's something for later. I think that's more or less correct. I think, yeah, because this is basically, I have the import path and I have, only thing is here, the module exports is not correct, module interfaces. So I am gonna need, when I do a lookup here, here I will need to do an fmap of interface exported. Because I think I prefer to give the entire interface and let this code decide rather than creating a... Maybe I'll change my mind on this. Actually, maybe not. Because I don't really... For the other stuff in the interface, do I care? Because I will need to keep a cache of the union of all the interfaces anyway. But the interface is what I'm going to persist in the interface file for incremental compilation. No, I think passing the entire interface makes sense. Okay. Okay, so again, I'm not going to change any of this. That should be fine. The local scope, however, is where things are going to be a bit different. because here I am doing a thing where I used to have a function called where was it? Did I remove it? No. Definition identifiers that tells me what names need to be put in the local scope, but I will want to do something a bit different for this now. I'm going to let each definition decide what it should um, put in the scope. Oh, I'm still using name for this. Those will probably be a bunch of base names now. Name has changed quite a lot since I've started the refactor. Yeah, here, likewise, a top-level declaration is probably now... Yeah, that's top-level declaration is not a thing that exists anymore. Oh, that's annoying. That is annoying. That means that in my interface here, when I say, oh, here's the list of identifiers that are exported, that is no longer correct. I need to instead have a hash map from identifier to role because there is no longer a role which is top level declaration. I have roles such as struct enum constant function type alias something. So I will need instead to have a hash map from identifier to role. Okay, so this thing has changed then. So this make role is no longer correct. It doesn't work at all. So this is no longer, yeah, okay, so this is no longer an S to list, this is no longer a set, this is a map. And here I don't get an identifier, I get an identifier and a role. So make role goes away in favor of just the role. Likewise here, role, make role goes away in favor of just a role. There we go. So what this does, by the way, is if a module is imported unqualified, then everything is put directly as like in the scope as being that path plus like qualified plus the thing. Qualified with a qualifier then will be the path at which this role will be accessible will be the qualifier plus the identifier, or the import path plus the identifier. If I export import everything from a module, then all of the things will be directly at that name and the import path plus the name and so on. So here, likewise, that's identifier and role. And I am putting the role here and the role here. Okay. Finally, when I have a specific list of identifiers, I need to do something different here. I need to get the role by doing a lookup of the identifier in the exported identifiers. And if I get nothing, is when I report that I'm trying to import something that doesn't exist. And otherwise, roll. Okay, that's fixed now. Now, let's move on to the create local scope. What is this return type? Why do I need this hashmap name to local definition? How is that part of the local scope? How does that make sense? So that is the scope, for sure. If I go back to the analysis, how am I using this? Local scope. Where is local scope defined? Create local scope. That's what is exported. Okay. The local definitions and the local scope. Yeah, I suppose I need the local definitions as well. Okay. So create a local scope is not the correct name for this function. I've used foreign here. I've used remote yesterday when I was looking at like how do I differentiate local versus things I have imported. I used remote yesterday. I'm gonna rename this as remote scope. Imported scope in this case. That's even better. So that's everything from the imports. I create a scope. Create a local scope is not just about creating the local scope, it's also about collecting other things. So I think this is more about parsing local declarations, which takes the local declarations which are annotated thing. I can rewrite this as a parsed definition. I need to fix something. The parsed definition. No. I think some of them will not be with location. So this is a with location parsed definition. Do I have, if I look at validation, I don't have a name for this kind of cache. Okay. So this is going to be the local definitions, their identifier. This is going to be a base name, and this is going to be the scope. Okay. So name no longer exists the same way. Check the comments more often. This is going to be a base name now. It's going to be base name, which is module name and identifier. There we go. A lot simpler. And now this is going to be, instead of doing this identifier thing, I'm going to have identifier and role. I had made definition identifiers give me a non-empty list. Guess that makes sense. Not sure why I did that though, but I'm gonna run this get declaration bindings, top level bindings of the definition. That will give me the identifier and the role for each definition in the list of all definitions. The base name will be that. The role will be provided by this. Wait, is that valid in Haskell? Can I do current name dot? Yeah, probably. I can probably do that, yeah. The implication here is that the module name is never fully qualified. Makes sense, I think. I'm not entirely sure I want to keep this. I mean, there's no reason not to, but I don't know if I like it. What I'm saying basically is that if I have a module name, like if this is module whatever, here test one can be referenced to as being foo plus food of test one, basically. Guess that makes sense to like be able to use to specify the current module. It feels a bit weird, but it must have been there for a reason. I'm gonna leave it. Okay. Is the module name just... Oh no, a module name is probably... Yeah, okay, that's fine. So the paths for a given identifier will be those two things. So what am I doing for the top level names? I am creating a hash map from the given identifier to a non-empty list of base name definition and role and paths. Okay. This is trying to find duplicates. But that's fine. Okay. This is an old-fashioned way of doing multiple errors. Abort. Yeah, that's old style. So instead, I'm gonna do the thing I do now, where I do an ensure of a get compose. And within that get compose, I will do this thing where for everything in the list of top level names, which gives me at every step an identifier and its corresponding entries. I think I might try to do that if the compiler allows it, just to avoid more indentation than required. It's not very happy with me there. Don't know why. Oh, because I forgot to do block there. There we go. Ah, even then. Well, so I'm gonna try that. So I get the entries, which is first of second. I could have written that instead. It's weird. Okay. But this is basically when the length, when this basically. Report this. Except, of course, this is a compose of try. I'm using this pattern so often that I'm kind of tempted to introduce. I'm tempted to introduce aliases for those, so I don't have to do this get compose with like an ensure compose and a try compose kind of helper, like something like and here try compose kind of thing. Hmm. I'm not even sure actually the syntax is bad. No, it should be fine. The bind here should be. Although I guess I could define ensure compose such that I don't like the name ensure compose and try compose. I don't like them. This would make writing this kind of stuff a lot easier though, is the thing. I'll have to think about it. I'll have to think about it. Okay, so the exports are going to be the keys of the top level names. If we have managed to go past this, that makes sense. Oh, perhaps here I would like to, rather than create this very complicated non-empty list of things, they extract a bunch of definitions here. Maybe I will want to instead, that's fine. That's fine. Yeah, okay. I think that's okay. So the difference is I no longer want the identifier here, the thing, the exported stuff, to be a hash set. That's a hash map from identifier to role. Which means I think this nonsense has to stop. So I think I'm going to rewrite this function. Yeah, I think I'm going to rewrite this. Because the top level names are indeed just a hash map from definition, but I don't need all of this check. The only thing I care about is the identifiers. That's not easy, actually. I guess. Okay, no, I'm gonna just leave it as is. But I'm gonna give the type of this nonsense. This is a hash map from identifier to a role and a non-empty list of a tuple of base name definition, which will be the basis for making a hash map of those things, and a list of path to of tuple path role, which will be the basis for making the scope. Okay? So this contains the role. Okay? Now this is second of that. Well, map second of that to remove the role here. And instead, the exports are gonna be that's going to be the exports here, and that's going to be, or yeah, that is. I'm gonna just map first on the top level names to get the role for each identifier. There we go. Okay, that is a bit better. Not great. This creating this very complicated thing, so I have for each identifier all the stuff to then basically check that it's empty. Like it's unique for each of them and then extract the stuff is, yeah, that's a bit ugly. I could instead do so this is try compose here, of this report here. And here I'll do a transformation. I know there's only one element. Which means I can return a new tuple, which is a tuple identifier and the head of the entries, which means now I'm down to instead I have the new top level names, which is instead I have a hash map from identifier to role and this stuff, but no longer a non-empty list, just one element of it, but still as a tuple. Can I simplify this mess? Because it works as it is, but I find it so unnecessarily complex. Can I make it better? Oh, and this is broken because of that. Okay, no. So maybe instead, rather than creating this horribly complicated thing, maybe I want to create instead a bunch of hash maps and only use the ones that make sense for my further checks, rather than creating this horribly complicated thing. I think that's better. So that means so instead here, rather than doing a from list of this, I'm gonna split this into three things. I'm gonna return a list. Okay, let me think for a second. Because again, this works as it is, but I don't like the unnecessarily complex thing of tuples of things that contains non-empty, that contains tuples, that contain tuple, that contain list of tuple. This is unnecessarily complex. I would like to do something better about this. What I will need to do is basically for each identifier, I will need to know the role. Because I think the base name to definition, that's based on the identifier, but I can create that afterwards. Okay, let's rewrite this function entirely. So the top level bindings is going to be a hash map from identifier to role. It's going to be obtained by doing, for each definition in the list of definitions, for each identifier and role in get declaration top level bindings, that hasn't changed, of the definition. So here, okay, I'm gonna keep something that I had before. I'm gonna keep this as being a non-empty list of role and definition. So here I can do the from list with concatenation of this list definition. And what I return at every step is the key is the identifier, and the value is a one non-empty list that contains a tuple of the role and the definition. Okay. From this, we can check that there is no duplication. So that's the ensure compose. Which does that. And will give me at the end. So it's going to give me something which is going to be solved checked bindings, validated bindings, the type of which is going to be a hash map from identifier to a role and a definition. So we have removed the non-empty thing, we have gotten one of them. Validated bindings will be an ensure compose of 4. I probably don't need to do for 2 lists, right? 4 is defined on any traversable, and hash map strict is traversable. And this gives me a hash map. Yeah, I don't need to do that. I don't need to, since I am... but if I do the traversable on the hash map, I will be only iterating on the value, not the key that I will need. However, perhaps that there is a traverse with key in this. Traverse with key. There we go. So this is a flip of traverse with key of this top level bindings, and the top and the function I'm applying on key value so on the identifier and the entries that I have, I do a try compose. Do the definitions the locations is simply I have a non-empty list, so this is the location of the second element of the entries. When that length is greater than 1, then there we go, and I report this error of the locations. And now I return the new value for this hash map, which is just the head of the entries, which is guaranteed to always exist because this is a non-empty list. I now have a hash map of identifier, role, and definition, from which I can create basically everything I want, because I can do the exports. The exports is going to be a hash map from identifier to role, and exports is going to be it's simply going to be a first of the validated bindings. The local definition. No, local definition uses the base name. Okay. So local definition will be a bit more complicated. Local definitions will be a hash map. I'm going to actually even, for extra readability, let hash map from base name to definition. Local definitions. Well, I guess I am calling something like past local declarations. Maybe I can just say definitions in this context. Exports definitions. This is going to be a map with key, but map with key, the key remains the same. So I have here to do a to list. I have to change the list entirely. Okay. So this is going to be a from list of do, and for each identifier and I'm going to ignore the role and get the definition in toList of the validated bindings. The base name is going to be this base name module name identifier, and I will return a tuple, which is going to be used here then for the from list of base name and definition. Then the last thing I need is the local scope, and that's going to be a bit more tricky. So, wait, is it? No, the scope is just no, it is path. So this is where it's going to be a bit more complicated. Okay, so it's going to be the scope is gonna be a scope. That's convenient. And scope is gonna be a from list again. From list with concatenation, actually. And this is gonna be somewhat similar. For each identifier and role in the validated bindings. I will need to do the paths, which was what I was doing here. So the paths will be aha, I'm gonna need to do a concat here, I think. Unless I do for each path in the list of paths, which is this. So for each identifier and role, for each path that I associate with this identifier, which is just the identifier or the module name, then the identifier, I return a tuple, which is the path to which the role is associated, and that's my scope. Well, except no, it needs to be a non-empty thing. That's pure role. There we go. And at the end, I can return exports definitions scope. Okay, I think this is so much better than it was. I no longer have the hash map of thing to a tuple that contains a non-empty that contains a tuple and a tuple of list of tuple. This is better. This is definitely better. We create the top level bindings with just rule definition. We extract the first one and we report an error if any of them is wrong. I don't like the name ensure compose and the try compose. I am tempted to actually. Thank you for reporting the bug. Thank you so much. I'm tempted to actually not give them a name that betrays their implementation, but a name that reports that conveys what I'm trying to do with those things. So I think ensure compose is more about ensure many. Like there will be more than one error. That's the whole point of this. Or do I do this with like, no, actually it's because it's a functor, it's because I'm depiling something that contains a maybe. Maybe ensure nested and try nested. That's a bit better, I suppose. Okay. Okay, but I think this is a lot more readable than it used to be. No more unzips, no more anything, and types at every level. Okay. So now that this is rewritten, I can probably keep them as... Do I want to... At the moment, I have the top level of the analysis call those functions, basically. Do I want to instead provide a like create top level scope, basically? I don't know. All of this is wrong anyway. All of this will have to change. So yeah, this is all broken anyway. I think I will have to wait until I have the monad diagnostic to rewrite all of this. Yeah, I will need to have so much more to be able to rewrite this file anyway. I'm gonna just be okay with this for now. Oh, there's one thing. There is one thing I don't do. I don't validate that the names are valid. I just check that they are not duplicated, which is a thing. But I should check. But this is in the resolved thing. But I could at least check this. Because I'm looking at every identifier. Yeah, I think I want to do that. I think I want to do that. Because otherwise I think that check is never performed. But now that means I have all of the identifiers at the top level that are checked, all the arguments, all the variables, all the template types parameters are checked. I think there is no longer any possibility for a wrong name to make it through. Okay. There is one more thing I just realized I'm not doing. Will it come back to me? That I need to do as part of this work. Validating the top level scope, creating the roles. Yes, I have assume the existence of get declaration top level binding, or maybe just declaration top level bindings, and this doesn't exist. So this needs to exist. Declaration top level bindings will be something that takes a past declaration and returns a list of tuple, yeah, of identifier and role. Oh, but that means the base name. That means getting the base name, actually. That's fine. It's not like creating a base name is complicated. So, this declaration top level binding thing is simply a case of which type of declaration do we have. Go to validation for this. Just, oops. I'll take this thing. Because for most of them, oh, most of them will be straightforward. Enum is the only complicated one. Because all of those return just one list of one element, which is gonna be the thing name of the info, and it's gonna be a role, which is gonna be something like a constant of the base name of the module name, which I will need as an argument, and the name info thing. So I'm gonna need the module name as an argument here. Okay. So here, when I do declaration top level bindings, I need the module name. I'll do this. I'll go back to common type alias info. So this is an alias name. And the only identifier that is put in scope from a type alias is the type alias name. And its base name is the module name and the alias name of the info. And this is not a constant, however. It is a type alias. To the point that I'm very tempted to make a helper function where a given solo binding that given some base name and a constructor will create a list of one element in which, well, not base name, I suppose. Identifier will create a list which is the identifier as the key and the constructor, the base name of the module name and the identifier. There we go. And now all of those become just solo binding. I'm going to change the order of those two things. This is a type alias. This is a struct. This is a constant. And this is a function. And their base name, well, their identifier is the alias name of the info. That's probably the struct name of the info. That's very likely to be the const name of the info. And that is in all likelihood the fun name of the function. It is indeed. Okay. Okay, and the only one that's complicated is gonna be enums. Because... Oh, and here... No, I will do the check. I was gonna say, what happens if I have an enum constant that's the same thing as an enum type? No, this will be checked as part of the things that are exported. If I have twice the same, it's gonna be checked as part of the things that are exported. Okay, we'll be fine. Oh, something that's gonna be complicated, however, is I'm gonna put those as constant declarations. My point is to say, okay, if I have an enum color that is red, green, blue, then in the top level scope, color is a type, it has an enum, but red, green, and blue are constants. But does that mean that then my resolution stuff will try to pass them as constant? Or do I need to basically fake them? Aha, this might be more tricky than I thought. This might be more tricky than I thought. Let's think about this. Let's think about this. Unimplemented for now. So, Here, I'm gonna say I'm gonna give the binding for each of the things in the enum. So I'll get the role for the thing that will go into the scope for each identifier. That means that at the end, I will have in my local definitions a bunch of constants that will have been created for the enum. But I don't know how to define those constants because they are tautological and don't need to be analyzed. So do I need to put them in the stuff that is... No, it needs to be in the scope. It needs to be in the scope. It needs to be in the scope, but it needs to not be in the definitions, I think. But if it's not in the definitions, then it will never be... Huh. Does that mean I need to create a new special kind? Oh, okay. That's not easy. So basically what I'm planning to do is to have something like a list that is going to be... The first element will be the name, the enum name of the info, and the type of which will be... Not const will be an enum of a base name of the module name and the enum name. So basically a solo binding of enum and enum name of the info, but that appended at the beginning of a bigger list, which is going to be for each constructor or enum constant in the enum values, output something that is going to be create binding, actually. Which is gonna be create binding of constant and the enum constant. So I can rewrite this as being concatenated with concat map of create binding constant of the enum values. That's what I'm planning to do, basically. To say in the scope of the top level of the module, there is the enum with the enum type, an enum name, and a bunch of constants that happen to be the values of the enum. The problem with this is that means I will register a definition. There might be a trick there. That's the trick. That is the trick. Okay, I know how to fix this. My problem is this. When I am then going to go through the resolution phase, it's going to be fine, because I will do a resolve constant, a resolve definition, regardless of what the role is. And I'm just gonna see a bunch of constants and I'm just gonna try to resolve them and it's perfectly fine. Well, no, because the constant of the enum will be pointing to the definition of the enum. So I will see a bunch of different enums, but there's nothing to do. So this phase will work. But it will be resolved as pointing to a constant that does not exist. And that means that when I do the validation, if I ever try to get a constant, there is a risk that instead of a constant, I'll get an enum. And I need at this point to be like, oh, I'm trying to get a constant, I found an enum. That means that the constant I'm trying to reach, its name is one of the constructors of the enum. And then I can get the actual constant expression. That's what I need to do. Okay. What will that look like? Can I do it ahead of time? Because I'm going to be passing a bunch of enum definitions. Nothing will happen there either. I think what will happen is in context. I will try to do a retrieve constant, and that will be retrieve definition, traverse, assert constant. So I'll try to get the definition based on the name that I have, which is like, hey, I have this constant with a name. Give me the corresponding definition so I can figure out what that thing is, basically. Which means I will obtain a definition validated, which for an enum is just the enum info. And that means that when I try to retrieve the definition for a constant, that definition might be pointing to an enum, despite the fact that the thing I had was a constant. Excuse me. And if that's the case, then in assert, I don't think assert enum is gonna be. Do I need assert enum? It's probably used only for context. Yeah. Do I use retrieve enum anywhere? I do use retrieve enum actually. Interesting. Oh yeah, I suppose. Yeah, okay, that makes sense. I'm finding something that points to an enum. I'm checking that the enum type is valid. Okay, that's all good. So I guess the assert constant here is the one where I'm gonna need to be like, oh, actually, if this points to an enum def, that's actually fine. And here I'm gonna need to check. Ah, haha, that's a problem. This will require the base name. So if I go back to context, when I retrieve a constant and I do an assert constant, I will need, so base name, assert constant, base name. Because here I need to, for sanity check, I need to check that the name I have is indeed, well, I need to find which of the constructors it is. So it needs to be one of them. Do I have anywhere a find of a constructor? Do I have a lot of finds? I have a lot of error messages with find. Do I have anything in the old code, in core perhaps, or in context? Did I have anything that would do this lookup? Let's look at enum, verify enum value. There we go. LM index. There we go. That's what I want. This is what I want. I can put that here. I'm going to do an LM index of an identifier. If I look back at name, how is it called? It's the name ident. Maybe I could just... It's fine. So that's the name ident of the base name. In the enum values, oh, here I still have the input output. That's not great. So it's the enum values of the enum info. And if I find this index, it's perfect. This becomes a typed int type of a const. How is it called again? Validated. It's a int literal const expression. Int literal const expression of that value I. If it's nothing, I report an internal compiler error. And there we go. And with this, we should be fine. We should handle constants, which means I can go back to what I was doing in the scope. And actually, this would be fine. Actually, this is probably fine. Yeah, I think it's fine. I think, and just for the sake of readability, create binding is just gonna create the tuple, not the list. So this is creating a list of one element. And this is creating one element at the beginning of a list, which is map of that create binding on the things. That avoids having a bunch of like more lists. Okay, and that should be everything for the scope. So at this point, what are we missing? We're missing the other phases. The simplification phase is written on the wrong state of the AST. That's going to need to be fixed. All of the things that are downstream from the analysis, all the lowering into AR is completely broken because it's all based on types that are no longer, like most of them no longer exist anymore. And we're still missing some of the validation. Because we do have all the top level ones. Validating type alias, validating struct, enum, const, and function type, and everything. That's all done. There's something that doesn't work with the enum stuff we've just done. There's something that doesn't work with the enum things we've just done. Oh, at this point, I will definitely use the compiler to try to help, like when I have done enough. But there is still a lot of the code that I have written with the assumption that something will be written that doesn't exist yet. So at this point, the compiler will just like nothing will work, and I know that. So I'll go through the things that I know need to exist. Like at least the functions need to exist, the types need to exist before the compiler becomes useful there, basically. Because for now, it's just gonna tell me like, hey, you are using a bunch of things that are not defined, which I know. So I'm gonna finish at least getting through the big things that are missing, and then when the big things that are missing are there, then I can go through. I can actually start using the compiler for assistance with finishing all of this. No, but there's a problem with this. There is a problem with this. It's not a big problem. No, I think it's fine. The problem with this is, again, I'm going to have a binding from the name of a enum constructor, enum value, to a definition of the enum. That means that in the interface of the module, while a module has been fully analyzed, I will persist in the hash map in the interface. If I go to interface, in here in this definition cache, which will be the validated definition for each base name, I will persist a definition that to a constructor of an enum associates the definition of the enum, which is redundant and not required, but it is fine because this will not be part of what is exported from the module and therefore cannot be imported from other modules. Therefore, no, it's fine. It's fine. It can, because since the exported thing will say constant, we will run into this particular case here. I should document here. I should redocument this because this thing here is crucial. Without it, the constants, the enum doesn't work. Okay. It is 1 a.m. Do I want to stop here? I have to be up in 8 hours. Is there something else I want to tackle before I stop? I really need to go through the monad diagnostic thing. That will probably be tomorrow evening if I am in a state where I can stream tomorrow evening. For validation, what is missing? Is there still a lot of unimplemented in this? There isn't any in this file, so all the top level stuff is done. What is missing is I do the function instantiation request, but I don't do function instantiation. So that means that all of the validation of statements and all of that is missing. That's a big part. That's the thing we can start working on. Okay. So that's probably going to be in analysis, validation, instantiation. Oh yeah, I need to fix this. Qualified as resolved. Oh, as resolved. As validated. This is a resolved definition, and this output may be a validated definition. Validated definition. Oh, and I need to remember to do the change. Validate T everywhere, which I need to do on all of the file in this as well. Okay. Now I can go back to instantiation, and this will have, actually go back to validation for a second to copy all of this. This will have an instantiate function that will take as an argument a request, which is this thing, a function instantiation request, and will return invalidate T for some monad M that will have more constraints later when we have monad diagnostics and some other things like this, will return a function info resolved, which will be the basis of the symbol map. So the thing that we can then transform, like we can try and lower into AR and then compile it into bytecode. Instantiate is unimplemented for now. But there will be also another thing I will need to do as part of like the public API of this thing, which will be, we have the skewed instances, which is the things we know we have to instantiate. However, when I instantiate a function, it might create more. So I will have to do something like instantiate all, which will be something in the validate T monad that will output nothing because it will just be updating the symbol cache. All symbols, I suppose. And what it does is that's going to be a control monad loop. Control monad loop. Which one is that? I could do a fork there, actually. Oh, it's on IO uniquely, and I don't want IO there. But I could definitely parallelize this. Okay. I will want some kind of while M, basically. And basically that is while that sequence of things is not empty. Can I do something that gives me... I think, yeah, iterate until is what I want. Or iterate while, it's the same thing. Yeah, that's what I want. So this will be a void of iterate until. What's different with the M version? It gives, okay, it starts with the, that's fine. This version is fine. Okay, so iterate until, and the thing I'm gonna iterate until is until the sequence import data sequence qualified as S, because I probably won't need set as part of this, I think. This will be I iterate until the set is empty, which is going to be null. The sequence, not the set. I think null is the one I want. Null indeed. So until I iterate on the thing until it's null, and the value will be the thing I'm going to be iterating on will be not sure why it's not happy about. Okay, it's fine. This will be something where I get all of the instances. I get them from the state. I'm just gonna, just in case I end up using sets, I'm just gonna do that. So I retrieve all of the requests from the state, then I set it to empty. So there is nothing, no instance to process after this. Is there actually something that swaps the state, like pops the state? I don't think there is. Control monad state. I want something that replaces the states and gives me the old value. I don't think there is such a thing. I'm using the strict one, but it's the same API. I guess I could use state for this, but it's fine. It is fine. So I get the list of instances that I need that need to be instantiated, and then I set the state to this. Then I traverse with instantiate the list of instances. Well, I guess I'm gonna rename this instance requests. That is a better name for what it is. So this is instance requests that I then set to empty. Then for each of those requests, I traverse with instantiate. And I'm going to traverse this so it's clear that it's void. And at the end of this, I will be getting, wait, control monad loops. Oh no, okay, it returns. But this is a bit silly. I think the iterate until M makes a lot more sense. Okay. So iterate until M is still with, I iterate until it gives me something that is null. The first value will be original request is this. And then we iterate until m. This takes the request and then returns the new one. So this is go and original request. And go, the function, is going to be step, actually, for once. Step is going to be a function that takes the request and does set them to empty, traverse to instantiate, and then gets the requests again. So then, after getting the request, this iterate until will check whether it's null or not. If there are some new requests, it will call step. Step will reset the set of the state here, like we'll put those at empty again, process the request. If any of them ended up creating more requests, then and so on. So that's gonna be that. The only thing is I need to make sure that I don't have things creating instantiation on a loop. And that is basically when I try to instantiate something, I just need to check, has it already been instantiated? If yes, I do nothing, which means no new thing will be created. So this instantiate will need to make sure that I have not already done the thing. So here, instantiate will take a function instantiation request, which is this thing. And the very first thing I need to do... wait, what did I change here? The very thing I really need to change here is the symbol cache is a name, so I need to compute the name, the actual name of this thing, which means then I can look into the symbol cache. Does it already exist in this module's export? If no, I need to do something. Does it already exist cached in another module's export? I can duplicate it from there. And if neither is true, then we have to do the validation. Okay, so that is already instantiated is uses their symbols, and I do a lookup actually I do a member of the name that I don't have yet. No, this gives me a function. No, this doesn't give me a function info. This just put it in the scope, I think. Will I want to? Yeah, I will probably want to try to accumulate errors. Okay, no, I'm getting tired. And there's more to do here. I will want to like accumulate errors and try to instantiate other functions, even if this fails. Because each function should be tried like instantiated on its own, basically. So I will want to try to do some git compose and stuff here. I will and have to reuse those new get like compose nested and everything that I have introduced. I need to use them for some of the code. And then I need to figure out how I do all of this instantiation and where I do the insertion into the symbol cache, but probably in this function. Okay, I'm gonna stop here for this evening. Hopefully, I'll be back tomorrow evening if I'm not too sick from the COVID shot, and otherwise, it will be either on Friday or next week. And I need to update. I've put everything on YouTube, but I have not yet published them because I haven't done the naming of the videos. I'll do that as soon as I can. So, thank you everyone for tuning in, and I'll see you soon.